A very good morning, everyone. Welcome to this webinar. Just to check that all is well, please, our panelists, are we all together? Can you just unmute and let me know if you're hearing me?
Yeah, I'm here.
Yeah, we are hearing you.
Can you all hear me?
We can hear you, but the video is not on.
Yes, I'm hearing you.
Hello?
Hello.
Hello.
We are hearing you.
Hello.
Please, can I get some response from the chat, please?
Okay.
Okay, thank you. Okay, thank you. I'm getting feedback from our participants online. So thank you for confirming that. Please, we'll begin in a very short moment. Okay, thank you very much once again. I want to say a warm welcome to everyone to this one-day seminar or an online seminar, a webinar on artificial intelligence. The topic of this webinar is AI, that's artificial intelligence, garbage in, filtered out. As we all know today, artificial intelligence is one of the hot topics around the world today. AI has been also declared as the fourth industrial revolution because it's permeating the space of life, every sector of the economy, every sector of human life as well. And so we will be looking today at the topic generally of AI, more or less an introduction. We have our speaker that I will introduce in a moment. But the idea is to learn about the theory and wide-ranging applications of artificial intelligence and how they enhance traditional computational processes. This is a seminar that almost everyone can learn from because it affects us differently with robots, with automation, and natural language processing coming up in different aspects of life, processing data, big data. So if you're in the computing field or in computer science or information technology, it's an interesting topic. And even people from other areas or other disciplines can learn a lot from it. So today we'll be looking at what is intelligence, how can reasoning be automated, and can machine really think and learn, and what role can artificial intelligence play in Africa's development. So all these topics will be considered today. So I'd like to welcome everyone once again, and especially our panelists. This webinar is put together by the African Center of Excellence on Technology Enhanced Learning, popularly known as ASTEL. It's a World Bank sponsored project of the National Open University of Nigeria. Members of the ASTEL team, which I will introduce in a moment. We have the director of ASTEL online, Professor Grace Joktan. We also have the director of academic planning and the program coordinator of ASTEL, Professor Neba Tanglang, also online. And a lot of the team members will be joining us as we proceed. So without wasting further time, I would like us to get an opening remarks and welcome message from the director of ASTEL, Professor Grace Joktan.
All right, good morning.
Director.
Yeah, can you hear me?
Yes, we can hear you.
Okay, good morning. And
good morning, Prof. We can hear you, though we can't see you.
Yes, I'm wondering, I've been saying the panelist video is not on. I can only see you and Chidi. All others are not on video.
Okay, turn on your video.
I have tried to turn it on. It's telling me something else.
I think you just need to turn on your video.
No, the host has off it.
The host has off it. It's not allowing us to.
The host has stopped it, the video.
Oh. Okay.
Host is.
Yeah.
No.
Yeah, sorry about that. Let me quickly check on that setting.
Yeah. Hello.
Maybe for the purpose of time management, you can proceed.
Yeah, I think I should proceed while she sorts that out.
Okay, please go ahead. Yeah.
Okay. Once again, good morning, our dear presenter, Dr. Tunde Adebola, the team of panelists that are here, ASTEL team, and distinguished participants. I once again want to welcome you to the first in a series of 3 seminars that National Open University of Nigeria, Africa Center of Excellence on Technology and Enhanced Learning is anchoring. The African Center of Excellence on Technology and Enhanced Learning is a World Bank assisted project that is hosted in the university, and it is aimed at enhancing the use of technology for education. And so the center runs 3 major programs for which we will soon operate at the postgraduate level, MSc and PhD. In the light of that, the center deems it necessary to host these sensitization workshops to enable the general public have an idea of the programs the center will be running, as well as what they stand to benefit in joining the MSc PhD programs of the center. And so this one on AI is the first in a series. Another one that will be coming up is the one on cybersecurity. That will be on the 25th. And we have finally the 3rd one on management information system that will be coming up on the 30th. I welcome you to today's seminar, and I hope that we will all enjoy and learn something from the area of artificial intelligence, whether we want to take it forward as an academic program or we just want to know what is going on in the field of AI, such that we will be able to learn a few short courses that will also be running in the ESTEL program. Once again, I welcome you and thank you for coming, and I wish us a successful and fruitful seminar. Thank you very much.
Thank you very much, Director of ESTEL. Sorry about this slight technical challenge about the video. We'll resolve it as we go on. Very warm welcome there to all of us regarding this seminar. So without wasting further time, we would like to have some comments from some of our distinguished participants. We have on board our Dean, School of Postgraduate Studies, Professor Samaila Mande, as well as Professor Neba Tenglang, as I said earlier on, and also the HOD of Computer Science, Dr. Vivian Nwaucha is also online. Our speaker today is Dr. Adegbola. I will hear more from him shortly, but I would like to give opportunity to our esteemed panelists, senior members of ESTEL in the university community to give a short welcome before we proceed. Professor Mande.
All right, sir. Thank you very much, Dr. Additional and our host. The director is Professor Grace Doctan, the director academic learning, Professor Neba Tenglang, who is also the program coordinator for this program, and our special guest of the moment, Dr. Adegbola. It is nice to have you for this event. I must say that this is something that is very, very rare. But because of the nature of ESTEL activities, otherwise, I mean, when we are coming to do any postgraduate program, you apply for a program once, you are shortlisted or whatever, you do the matriculation, and then you commence your lecture. But because this one is something that we're trying to have some kind of global standard, best practices, and that is the more reason why. Part of the program that we're to offer, we are now having what can now be considered as an appetizer. So for each of the programs, we're having an appetizer element. And so this appetizer element is the one that will indeed be a motivating and captivating tune for the program. This is like a sick tune. In broadcasting, there's what we call sick tune. That's when you are heralding your program to now have a signal tune that people understand. And for that, we're having eminent people in this discipline, in this specialty, who now take us through. And I know that our postgraduate students of National Open University of Nigeria for this ESTEL program will find this a worthy event. And I will want a situation whereby after the whole event, they should go out to spread the gospel of ESTEL, because it is not easy for us to be doing this kind of, they are fully aware of other things. But because of the nature of ESTEL program, being a World Bank funded program, and that is the more reason why we're having this as an appetizer, and as an appetizer, a teaser for us to now move on. I want to commend the participants for this program, and then the eminent scholars that have been invited, particularly Dr. Adegbola, who is now heralding this aspect for us. We appreciate, and we're ever ready to listen to this menu as you now try to open the menu for us to now do this. On this note, I want to thank you so much, and let participants be attentive. Jot down all they want to jot down, and when it's time for question and answer or comment, they can also use the facilities there to send their question and everything as we move on. Thank you very much for everything, and ESTEL, I say great to you people. Thank you.
Thank you, sir. Hello?
Hello?
Yes, hello? Can we have Professor Nebat Tanglang, Coordinator Academic Programs? Hello? Hello?
Hello, we can hear you.
Yeah, can we have Professor Nebat Tanglang? Okay, if he's not on, because I noticed in the chat, he said he has internet issues. Can we have the HOD Computer Science, National Open University?
Okay, good morning, everyone. Once again, Excel Director, Professor Grace Joktan, the Dean School of Postgraduate Studies, Professor Samaila Mande, Professor Nebat Tanglang, even though he's in and out, I guess he will join us very soon. The Director DLCMS, who is also a research team leader, and our guest speaker, Dr. Adebola. Distinguished participants, you're very welcome to this event. And I don't know about you, but I know that a number of people have been excited because artificial intelligence is relatively new everywhere, and we now want to be exposed to the intricacies and also to the applications of this program. So I'll invite you to really pay attention and also be able to make up your mind whether this is really the program that will be good for you. All the best. Thank you.
Okay. Thank you, Dr. Vivian Waucha, the head of Computer Science, National Open University.
Can you hear me?
Yes, we can hear you, sir. Professor Tanglang is on.
Let me make my quick remark because of the challenges I'm having here. Good morning, all.
Good morning, sir.
Yeah, we are all welcome to another TISA. And Apataga, as one of the speakers has spoken. This is one of the series of events organized by Estelle to sensitize members of the public on the new program that we are about to mount. The essence is for people to know that this is what is happening in Estelle. It's part of our calendar and it's the activity that is within the calendar. Today's topic, very, very interesting, garbage in, filtered out. This is a new adage. The old adage is garbage in, garbage out. Today we are going to hear how we can filter garbage that have been data that have been given to us, so that we don't produce the same garbage, but we are going to get something different. It's like recycling, making use of garbage in a better way. I wish you all the best. And to all our participants, pay close attention, take notes, ask questions, and then at the end, you will be fulfilled. Thank you. God bless.
Thank you, Professor Nebat Tanglang, the Director of Academic Planning, as well as the Academic Coordinator, Estelle. Is Dr. Adewale on?
Yeah, thank you, Prof. My connection went out, but I'm back now, thankfully.
Mm-hmm.
Even you.
Okay,
all right.
So I think we'll just proceed immediately. Already I can see that our speaker has already started sharing his screen. Just a brief introduction and...
Dr. Adewale, 1 minute, please.
Oh, okay, fine, that's all right.
Yeah, is Professor Abdullahi around, the Deputy Director, Estelle? Professor Abdullahi, are you in? Okay, we can move on.
Okay, I'm also aware that Dr. Greg Onworthy, that's the coordinator for artificial intelligence, is also online.
Okay.
We'll sort out the technical problems and do a proper introduction shortly. But meanwhile, I think we should just proceed straight with the workshop, the seminar. So our speaker today is somebody that has been in the field of artificial intelligence for decades. Okay, he's the Executive Director of African Languages Technology Initiative, ALT-I, and he's also the President of Tiwa Systems Limited. He has taught in several universities, including University of Lagos, University of Ibadan, and many others I could name. And presently he is the content editor and also a course writer for the program Artificial Intelligence that is being offered by Estel in the next few weeks. So without further ado, I want to say, Professor Adegbola, can you please take over? Thank you very much.
Thank you very much, Dr. Adewale. The professor one is new on me. Thanks. As has been said, my name is Tunde Adegbola. It's my pleasure to make this presentation on artificial intelligence. And I have chosen the rather provocative title, Garbage In, Filtered Out. But towards the end of the presentation, we might just change the tone of that title to Garbage In, Filtered Out. Your guess is as good as mine. But the whole idea of this short, brief presentation, introduction to artificial intelligence, is to just give a general idea about what is artificial intelligence and to bring a lot more people on board on artificial intelligence, because it is very, very important. It is one of the most effective and exciting areas of knowledge today. And I sense a deficiency in Nigeria at the moment in the area of artificial intelligence. And it is necessary to make up for this deficiency, because we need a critical mass of people who can use some of the techniques that artificial intelligence offers. So I must say a very big thank you to Estel and the National Open University for thinking it fit to develop a program on artificial intelligence so that Nigerians can get on board on artificial intelligence. Let me start by trying to answer the question, what is intelligence? Because if we are to address artificial intelligence, we should at least know what intelligence is. We do know what artificial is. Artificial, I mean, from the root, art, has to do with anything that has to do with human creativity, things made by human hands, not naturally occurring. We know there's naturally occurring intelligence, but we have also, we are beginning to create intelligence made by man, and that is what artificial intelligence is all about. I must say that the question, what is intelligence, is a rather bewildering question, because it has not been very easy to define intelligence. Psychologists, cognitive scientists, philosophers, various scholars in various areas have engaged the question of what is intelligence, and each time there has been a kind of bright idea, there has always been one thing or the other that has put a kind of question mark on the definition that has been given. This stands to reason because we need intelligence to define intelligence. So if you do not get a mirror how then do you know the shape of your face? So if we are trying to define intelligence, and it is intelligence that we are using to define intelligence, we definitely have a bit of a problem in our hands, because intelligence needs to be able to stand outside intelligence so that it can see itself and define itself. Where we end up with that, only God knows, but at least some scholars have come out to say that intelligence is not just one property or one characteristic. The scholar Howard Gardner has proposed the idea of multiple intelligence, talks of various types of intelligence, emotional intelligence, what we are normally associated with intelligence, intelligence quotient, and all that, and even what kinesthetic intelligence, the kind of intelligence displayed by Kanu Nwankwo and Gigi Okocha. So all these are various aspects of intelligence. So it is bewildering to try to define intelligence. The comfort, though, is that we can easily identify and recognize intelligent behavior. Even though we may not be able to define intelligence, when we see somebody behave intelligently, we can say, oh, it is intelligence that caused this kind of behavior. So in trying to get around artificial intelligence, therefore, we have taken comfort in the fact that we can identify and recognize intelligent behavior. So even if we have problems defining intelligence so that we can say this is what artificial intelligence should be, we at least have the good fortune that we can at least make the computer behave like somebody who is putting up intelligent behavior. If we look carefully at this whole thing of intelligence, we find that really and truly at the end of the day, at the very, very bottom of the whole intelligence question is the issue of information. Information is that thing that we use to make correct decisions and take appropriate actions. All use of information is towards these two main goals. Whenever we are considering intelligence, whenever we are considering information, what we are driving at is to develop a capacity or to get the facility to make cognizant decisions and take effective action. So then the question reduces to, how do we get information? Or put in an ordinary way, how do we know? How do we know what we know? How do we get to know what we need to know to be able to take the right decisions and make the right decisions and take appropriate actions? I will not bore you with philosophical positions of empiricism and rationalism, but suffice to say that there are schools of thought in philosophy that say that all we know come from all we sense from our environment. That is the school of thought of empiricism. People who believe that any knowledge, any information that is worthwhile has to be observed from the environment. Whereas on the other hand, the rationalists say that true information comes from reasoning and not necessarily what we sense from the environment. They argue that our sensors, our sensing faculty, have their biases, have their difficulties, so we cannot really stay with that. So it's good enough for me to establish that these two schools of thought exist, and they exist side by side. And a lot of what we'll be saying will be touching upon some level of empiricism, some level of rationalism. The first and primary way by which we know is what we can describe as the approach of encounter and recall. You encounter an event and you remember it. So what happened in that encounter, you recall. So that is one way of having information. And we may easily categorize that as an empiricist understanding. Anything we encounter, we can remember, and that information is there with us. If you remember when you were a child, there was a time you were taught to memorize 1 times 1 up to 12 times 12. I don't know whether they still go to 12 times 12 because I don't think the dozen is a very important thing anymore. But you had to memorize all these. So whenever somebody poses the question to you 2 times 2, you just say 4. That is because you are recalling that information from memory because you have encountered it before. Now, this approach to knowing is handled in computers by the whole subject of database systems. Database systems are systems that bring together related data, put them in some kind of relations so that you can, from one field of data, get to other fields of data and have a kind of holistic view of data leading to information. So the encounter and recall approach to knowing is handled in computers by databases. And let me say here that the ability to encounter and recall, no matter how voluminous what you can recall is, does not entail intelligence. You may think this sounds strange, but let me remind you that the book from which you read a lot of what you know, the books from which you read what you know, have better memory than you. The books can recall, they can out-recall you, but yet we cannot say these books are intelligent. So when we put data in databases, the data does not say anything until we try to engage it and try to retrieve information from it. So encounter and recall is not an intelligent process. Another way by which we know is by calculation. The answer to 2 plus 2 times 2 comes out immediately when you ask somebody. But if you ask them 573 times 758, well, the really practical person will probably get a calculator or get a pen and paper and start to work at it, using the information that they can recall from 1 times 1 up to 12 times 12 to work out the answer to 573 times 758. That is another way by which we can know. And that is achieved in computers through the whole processes of number crunching. Computers do very, very well at that. They do them fast, they do them accurately. We cannot fault computers on that. But we must remember also that ability to do complex calculations is not necessarily intelligent behavior. I'll remind you again that abacuses, sorobands, all these old calculating devices, or even the adding machines in which you have wheels with numbers on them, and you roll the wheel 1 time, it does something like a multiplication by 1. You roll it 2 times, it's like a multiplication by 2. You roll it 3 times, a multiplication by 3. We cannot say that these devices are intelligent. So, ability to calculate does not entail intelligence. Some of the algorithms by which we calculate, the long multiplication algorithm, for example, it took an intelligent person to develop that algorithm. But once it has been introduced into mathematics and people use it, then there's no more need for intelligent behavior. All that is left is just to mechanically carry out the steps that have been prescribed in the algorithm. So calculation is another way of knowing, but it is not intelligence. Calculation is not intelligent behavior. The third way of knowing is that of reasoning. We talked about calculation earlier on, which actually takes existing information or data, manipulates it to create something else. But we find that we are limited to only numerical manipulations. We can only deal with numbers in that. If we ask, for example, who is Abu's uncle, and you know Abu's father's brothers, you know Abu's mother's brothers and sisters, if you do not have the capacity to use rules to infer unknown information from known information, you are not able to reason. But it is here now that we start getting at intelligent behavior. When we get to the position where we are beginning to use reasoning, where we are engaged in symbolic manipulation in contrast to the numerical manipulations which we were doing in calculation. So one of the primary objectives of artificial intelligence is to bring about a situation where we can actually engage in numerical and symbolic manipulation on computers. Until not too long ago, with the work of people like Stephen Wolfram, it was impossible to use the computer to do algebra, because algebra involves manipulating symbols rather than manipulating numbers. So manipulation of symbols becomes a very, very important aspect of answering the question, how do we know? Because we can, from symbolic manipulation, find out what we do not know from what we know. And this brings me back to the whole question of knowing by encounter and recall. There are two main problems with knowing by encounter and recall. The first problem, and as has been exemplified in the need to be able to multiply, is that you can never remember as much as you need to know. And that is why you did not bother to learn the multiplication of all pairs of integers. Of course, there are infinite pairs of integers. So how can you memorize all the answers in your brain? So the first weakness of knowing by encounter and recall is we do not have enough memory to be able to remember everything that we need to know. Second problem with encounter and recall is that there are many things we had better not encounter before we recall. It is not the best to get a snake bite to know that a snake is poisonous. It is important to be able to find alternative means of knowing that. So important and powerful as encounter and recall is, there are very many things we'd better not recall. We better not encounter in order to recall. So these are the three main ways by which we know. And of the three of them, only reasoning is intelligent behavior. And we shall be looking further as we go on into how we can begin to get computers to reason. We have looked at recall, we have looked at calculation, we looked at reasoning. It is instructive to look at these three from the point of view of the hierarchy that you find between data and knowledge. We say that data consists of raw facts and figures. Information is processed data, and knowledge is applied information. So we see a gradation there. And when we look at recall, calculation, and reasoning, we might see a kind of parallel that we can recall data, we can encounter data, we can calculate the data into information, process it into information, and we can apply rules to the information to get knowledge. We say that knowledge is applied information, but to operationalize knowledge, we say that knowledge is information with the rules of its application. When you know the rules by which you can apply knowledge, it is then, by applying information, it is then that the information becomes knowledge to you. Now, having spoken so much about what is intelligence and how do we know, let us take a sneak look at the human cognitive system. Because in our whole effort to make computers behave intelligently, what we are trying to do is to give some of the capacities that for now only humans have to computers. So in order to be able to do that, it is necessary to look at how humans do these things. So that's why we look at the whole question of human cognition. One of the many definitions of AI is that AI is the branch of computer science that seeks to solve complex problems in more human-like fashion. That is, the way we are trying to solve this problem, we want to borrow a leaf from humans, see how humans solve the problem. So for that reason, whenever we are working in AI, we usually take our cue from humans. There are some methods that do not exactly replicate how humans do things, but by and large, we take our cue from humans when we do artificial intelligence. Basically, humans engage their environment by sensation, perception, and cognition. We were taught this by psychologists, that humans sense their environment by one or more of their 5 senses. Sensation is basically excitation of one of the senses by stimulus from the environment. And this stimulus is usually just a change in circumstances. You will be shocked to know that there are lots of things happening to you at the moment that you don't take account of. But if there's a slight change, then you take account. But if there's no change, you are not really aware of what is going on. And I will remind you that as you are sitting there now, until I'm telling you now, you've forgotten that you are wearing a pair of shoes. Now that I've told you, it's beginning to pinch you. But if the shoe had got a little tighter, you would have known. So that's what we mean by sensation. Whenever the conditions in that environment changes, you get sensation. Then the next is perception. Perception is the interpretation of what you sense. So in a way, when you sense, you process the sensation and it produces perception. If you are following me carefully, you will have started seeing a parallel between encounter and recall with sensation, calculation or processing with perception. So perception is interpretation of what you sense, while cognition is the totality of sensing, perceiving, interpretation, and application of what you have sensed. Cognition is at the very, very core of human intelligence. Cognition is if you are looking for how humans behave intelligently, study human cognition. And Psychologists have given us a lot of information on that, but in recent times, there has been a need to even deepen our knowledge of cognition, and that's why the field of cognitive science has kind of become an offshoot from cognitive psychology. Cognition is based on concepts and propositions. What is a concept? A concept is a mental representation of a class of like objects based on their core characteristics. What we are saying here is that when you talk about concepts, you are talking about a mental representation. For example, if I ask you whether you have ever seen bird, B-I-R-D, you may ask me, what do you mean? Do you mean a bird? And I will say, no, I don't mean a bird, I mean bird. And the reason why you had problems dealing with my question is because really and truly, bird does not exist. There's nothing called bird. Bird exists only in your brain when you bring together all the individual birds that you have ever seen and you have created a class of like objects based on some common characteristics you see in them. So a concept is a mental representation. It's not really a reality. It exists only in your brain. A proposition is a statement that connects two or more concepts. For example, we say birds fly. Bird is a concept because you have various animals that can be classed as birds, including penguins, the so-called flightless aquatic bird. Flight also is a concept because kites fly, paper aeroplanes fly, real aeroplanes fly, ducks fly, even human beings fly in the wrestling ring. So flight is a concept. So when you bring the two concepts of bird and the concept of flight together to say birds fly, you have presented a proposition. And once you are able to understand propositions, once you are able to see things happening in the world based on propositions, you are beginning to get at the core of intelligent behavior. It will surprise you that human beings do not see the world as a collection of objects. It may appear to you as though human beings see the world as a collection of objects. No, we human beings do not see the world as a collection of objects. We see the world as a collection of concepts. And that makes it a lot efficient because we do not have to memorize the characteristics of each element, each object that is a member of a concept. Once we have the idea of that concept and we have been able to put a particular object into a class that encompasses the concept, then that is the way we'll deal with it. And the good thing about that is that once you are able to categorize an object into a concept, because you know the characteristics of the members of the concept, you can infer that the object you classify into that concept also has these characteristics. And if you are following me closely, you will see that we seem to have solved the problem of the experiences we had better not encounter in order to be able to recall. So once we are able to look at the world as concepts rather than objects, the first thing we gain is that we don't have to remember too much. Once we remember the attributes of a class that is encompassed by a concept, we can infer that all members of the class share these attributes. So we therefore have solved the problem of having to recall much more than our brains can handle. And also we have solved the problem of having to encounter dangerous phenomena before we can recall them. So I hope you are following me, and you are now beginning to see that this thing we refer to as intelligence is beginning to emerge as a capacity to be able to remember a lot more than our basic mental faculties can accommodate, and a need to avoid certain experiences before we can recall the results of these experiences. So we can say that humans learn categories of objects. When you learn, at the end of the day, as we go on, you will see that when you say you are learning, basically what you are doing is you are learning the categories of objects. You are conceptualizing, as we say. You are creating concepts, and you are beginning to understand what objects belong to what concepts, and that is what you do when you learn. The question now is, can we make computers do the same? And that is what we shall now direct our attention to. How can we make computers do the same kind of thing? So in a nutshell, we are seeking to develop machines that reason. And in order to do that, let's look at the whole idea of reasoning a little more closely. Basically, reasoning is a process of drawing logical inferences. That is, you have not seen something. There's something you have not seen, yet you are able to know about it. You are able to make inferences. You are able to use what you know to infer what you do not know. These are very, very important capacity, and that is the bedrock of intelligent behavior. Reasoning engages the faculties in contrast to the senses. Encounter engages your senses. You use your senses to get information from the environment. But reasoning gets information from within you. You've got some information, you've manipulated the information you got to get more information. Reasoning is not very much concerned about feelings or desires. If you reason properly, more often than not, the result of your reasoning will not be what you desire, because we usually desire that which is not realistic. So reasoning engages our faculty. It does not work basically on our senses, even though things that we sense feed into our reasoning processes, but the results we get from reasoning are not fundamentally sensuous. It's not about feelings, it's not about desires, but about what the faculty produces. So a lot happens from within you, within you, rather than from around you. The senses are concerned about the environment, but the reasoning is concerned from what happens within you. Reasoning involves reflection and deliberation. Contemplation of alternatives. You check it. Will this work? Is this better? Let me try this. Maybe this is better than this. And you line up these alternatives, and based on experience, you take which you think is the better of these alternatives. So basically, reasoning has to do with deliberation, reflection, contemplation of alternatives, looking at various options and trying to find the most appropriate, or probably sometimes the only appropriate in a given situation. And when we talk about thinking, talk a lot about thinking, and thinking is one of those elements of human behavior that are intelligent behavior. Because when you read a poem, you are not thinking, you are just regurgitating. When you regurgitate definitions, you are not thinking, you are just regurgitating. But when you begin to look at one definition and another definition, and you are bringing together commonalities between the two elements, and you are beginning to see some new things, then you are reasoning. And thinking is reasoning about something specifically. Thinking is the act of reasoning. Finally, I will talk about understanding, which is another very, very important idea in relation to intelligence. Understanding is the capacity to infer the unknown from the known. There are things you know, and you are able to put some of the things you know together and use that to infer what you do not know. Reasoning is realized in computers as search. We'll be talking about search in the next few slides, and I think this will be my last preaching slide. We'll now be talking more like engineers and computer scientists stuff. Done enough preaching. So we want to talk about machines that learn. We've talked about machines that reason. Learning is about attaining better understanding, better knowledge, better behaviors, better skills, better values, better attitude, better preferences. Note that as a prefix to all these attributes, I had the word better. The implication here is that learning is a process that brings about change. If you have learned and you have not changed, if you claim to have learned and you have not changed, you have not learned. Learning brings about better understanding of things. Learning brings about better knowledge about certain things. Learning brings about better behavior, behavior that is more attuned to society. It brings about better skills, better values, better attitudes, and better preferences. Basically, learning is about arranging human experiences into logical and more efficient categories. Remember, we've talked about concepts, we talked about groups, talked about classes, talked about categories. So a whole lot of learning is just about arranging life experiences into logical and more efficient categories. And you will find out that learning boils down to three main things: classification, clustering, and reinforcement. Classification is the process of assigning objects into predefined classes. You see an animal is walking on two legs, it has a beak, it has feathers, it has wings, and you put it in the class of birds. That is classification. And even though you have never seen that particular bird before, just because you have, by looking at some of its core characteristics, classified it as a bird, you can infer that when that bird is going to reproduce, it's not going to give birth to a live bird. It's going to lay an egg. That is knowing, finding out the unknown from the unknown. And we'll find here again that this process of classification is one that helps you to create concepts. The other process that involves learning is clustering. In clustering, you do not have a predefined class. You just have objects, and you find commonalities in these objects, and you are able to cluster the objects that have commonalities into the same class. And reinforcement. Reinforcement is another very important aspect of learning. It's also, in a sense, it's a thing about, it's about classifying or clustering, looking at groups, because you look at a number of things, you look at the number of behaviors, you look at the number of results, you look at the number of achievements, and you decide this is good, this is not good. The one that you find good, you reinforce yourself to do them. And the ones that are not good, you impede yourself at doing them. So basically, between those three ideas, classification, clustering, and reinforcement, you'll find that a lot of what we human beings claim to learn has been catered for. And this is why the whole of machine learning, which is a part of artificial intelligence, looks at classification as supervised learning, clustering as unsupervised learning, and reinforcement as reinforced learning. As we said, this address the two weaknesses of encounter and recall, and it offers a lot of cognitive efficiency because you're able to remember a lot more than your brain can easily take. Learning requires knowledge and understanding. Now, we've been talking earlier on, we've been talking about data and information, which is just about knowing, but now we are not talking about knowledge and understanding. Knowledge and understanding are ideas that are able, they're ideas that help humans to produce information that is not readily available from the environment, but ability to use what you get from the environment to get new data. So a major task of AI is to give machines these abilities. We've talked about machines that reason, and we talked about machines that learn. So between machines that reason and machines that learn, we find that a whole of what we refer to as artificial intelligence has been catered for. Generally, artificial intelligence can be said to involve three main types of algorithms. Computers always work with algorithms, but in artificial intelligence, we can group the algorithms that are used into three main algorithms, and these are search algorithms, logic algorithms, and learning algorithms. Traditional computing is about applying specific algorithms to specific problems. Every problem you have, somebody sits down, develops an algorithm, and that algorithm is used in engaging that problem. So that every problem you have has its own algorithm. And this is part of the origin of this maxim of garbage in, garbage out. Because once you get the algorithm wrong, you're going to get the results wrong. And we'll be talking later on about algorithmic bias. But in contrast, artificial intelligence tends to apply one single algorithm to several unrelated problems. And that's part of the power of artificial intelligence. You may have one single algorithm, for example, the search algorithm may be used to find the way home from a new location. It can be used to find how to do something better. It can be used to find the meaning of a sentence in one language in another language. So we find that these algorithms, they work with totally unrelated problems. And that is a major facility of artificial intelligence that we should take account of. Now, these three main algorithms, like I said, are search algorithms. And a search algorithm basically is what we call a generate and test algorithm. So the search algorithm will look at a problem, generate a candidate solution, and test it to see whether it actually solves the problem. If it doesn't, it dumps it, takes another one, and goes on and on and on, looking at various possible solutions and dumping them. Then the next is a logic algorithm. Logic algorithms are algorithms that can be used to infer the unknown knowledge from known knowledge by the use of various types of logics. We have various types of logics. Probably two of the most important for artificial intelligence is propositional logic and predicate logic. So in logic, we are able to give rules of the form if, then. So that we say if the if is taken care of, then we can assume the then, which is part of this thing about using what you know to infer what you do not know. And it's important to state here that this is not the kind of if-then that we encounter in conventional computing, in which we actually, the answer to the if is embedded in the question. In this case, it's a matter of if, for which we don't really know what the answer is. So we are now having to use intelligence to find the answer. And the third general algorithm that we find in artificial intelligence is a learning algorithm. That is algorithms that learn categories, algorithms that look at objects and put them into classes, into clusters, or applies the carrot or the stick. That is, you do something, you are punished, or you do something, you are rewarded. And by that doing, the computer is able to recognize the behaviors or the encounters or the responses that produce the carrot or the responses that produce the stick. So these are the three main algorithms. So let us start by looking at search as reasoning. We've talked a lot about reasoning, and the way we achieve reasoning in computers, in artificial intelligence, is by searching. Let's consider the problem down there. We have A plus B equals AC. AC here is not A times C. It's like saying 1, 2 for 12 or 3, 2 for 32. That is, there is a number A, you add it to a number B, you get a number C. And well, you get a number AC. Like I said, it's not AC as a multiplication. It's like saying you add 9 to 8 and you get 17. So A will be 9, B will be 8, and you get 17. A bit of contradiction there, but just let me get away with it. So the question that we are asking here, this is not a simple simultaneous equation. Computers can easily solve simple equations. They can solve simultaneous equations using the Gaussian elimination, no matter the number of unknowns and the number of, as long as you have sufficient number of equations, the Gaussian elimination will solve it with computers in linear algebra. But in this case now, what we have is a bit more complex, or at least different. The difference here is when you add A to B and you get C, is that C a unit number or just a unit part of a 10th number? So if you add A to B, is A to B equals C, or is A to B equals C plus 10? Because if you add 7 to 7 and you see 4 under the 7 plus 7, the 4 is actually 4 plus 10 because you've carried 1. So when you are dealing with that kind of problem, you are having to consider alternatives. And remember what we said about reasoning. Reasoning is consideration of alternatives. So in this kind of problem now, you are considering, well, if I say that A plus B equals C, will I be right at the end of the day? If I say that A plus B is equal to C plus 10, will I be right at the end of the day? And at this juncture, you do not really know. You only know when you look at what is to the left of C, and you find that, oh, if we add A to B and we get C at the unit and get A at the 10th, it means that the two numbers are such that you don't get only a unit number. Now, you know that when you carry in addition, the only number you can carry is 1. You can never, there are no two numbers, no two unit numbers you can add that will make you carry 2. So if you carry 1, it means that A is 1. So if A is 1, it means the A on top too is 1. So it means that when we add 1 to B, we get C. And when we get C, we will be able to reason that, well, that C is actually C, the solution is actually C plus 10. So you now see that we are not doing straightforward algorithm of addition, a long addition. It is a contemplative process. You are thinking, what will happen? Is this the right one? Is that the right one? And there are situations in which you do not know which is right until you get to a dead end somewhere. This is even a more serious problem. You add D to E, you get Y. You add N to R, you get E. You add E to O, you get N. You add S to M, you get O, and you carry 1. Well, that M we are getting already is 1. So the M of the more also is 1. So that way, at each of the additions, is it a unit result or is it a 10th result? Does it involve carry? The only one in which we are sure there's a carry here is S plus M that produces O and an M in front of it. Now, if we look at this tree, we can see the various possibilities of that, just that simple adding send to more to get money. Now you see that on the right, we have the options of carry. And on the left, we have the options of no carry. And you will appreciate that immediately, even before we've gone to the first, second, third level, we do not even have enough space to put the next level, which is the level at which we are adding more to get. So when we put it on a table like this, we can then now start trying out various options of, is there carry from the left, from the first column, from the first digit to the second digit? Is there carry from the second digit to the third digit? Carry from the third digit to fourth digit, and on and on and on like that. And when we do that, we are actually beginning to reason. The time now is 11:43. When should we take questions, please, Dr. Adewale? Hello? Professor
Yeah, we are following you, and I think...
Okay. I'm just trying to... Okay, all right, so I should continue.
Yes, we'll take questions, stop around 12, so that we'll continue in the afternoon session as stipulated in the timetable.
So we'll take questions at some point. 12.
No.
We'll take questions now.
Yes, we can take questions. If you reach a logical point, we'll take questions.
Okay, I think I'm at a point now. Let me look at my next slide. Okay. I think we're at the point now where we can take questions, because we can then put all these philosophical aspects of the whole problem behind us and start doing computer science. Yes, maybe we could take questions now.
Okay, thank you very much, Prof, for taking us through this very interesting and really, really informative session. Please, panelists, as well as our distinguished attendants, it's time for us to take questions and interact back and forth with our seminar speaker, Dr. Tunde Adegbola. So please, if you want to ask a question, there is a facility down on the platform, on the Zoom platform. If you look down, you see where you can raise your hand. So please do feel free, raise your hand, and I can allow you to speak. And if possible, we can see you. Another way we can also ask questions is by typing it on the chat menu there. So please, you can also type your questions. I will read them out, and then Dr. Adegbola will answer for us. And Dr. Adegbola, please, we've not actually seen your face, so if you don't mind, you can also...
That's because you're not looking at the screen.
Doing now. Oh, okay. Okay, I actually passed. All right, okay.
Thank you.
Now I can get to see it, yeah. So our panelists as well. So, well, I see a question, not a question, but a comment earlier on from Ibrahim Adeyanju, who is asking if participants will get a copy of the presentation. So he actually asked the panelists and who would like to ask if that would be possible.
Oh, yes. I can make the slides available. It's
okay.
I think it has become now Estelle property.
Okay, thank you very much. There is a question from Oge. He says, I'm struggling to understand how calculation does not imply intelligence. Can you explain a little bit more?
Okay. Calculation is really a mechanical process. Calculation is a reality. If you put 2 oranges on the table and you put another 2 oranges, you don't need any intelligent system to turn those 2 oranges to 4 oranges. It's just a given. If you take a wheel and you write numbers on it, and the wheel has sprockets, you can use the turning of wheels to do calculation. You can use, you know, these abacus, sorban that you see in nursery schools, those things with some piece of little metal and then red, yellow, blue, orange balls that you can slide back and forth. But just by sliding those balls, you are doing calculation. Are we suggesting that that device is intelligent? So calculation is not an intelligent process because it can be mechanized. It can be mechanized. It can be achieved by very, very simple mechanisms. And the ability to calculate, the fact that you can calculate does not make you act intelligently. You need other things to use, to apply the results of your calculation to become intelligent. Your calculator, that calculator you carry around, can calculate, but it's not intelligent. I can understand why you feel that calculation is intelligent behavior, because many of us had managed to get first-class degrees just by calculating. I'm sorry, it's not intelligent. And that's why many people do well in the exams, but don't do well in life. Because there's a difference, marked difference between calculating and being intelligent. I hope it answers the question.
Right. Thank you very much. I see Mr. Abdullahi Kawu. He raised his hand. So, Mr. Abdullahi, can you ask your question?
Yes, thank you very much. Prof, I do not understand the more money algorithm you're trying to explain. I understand the A plus B equals A C,
okay,
but not the one that follows. So can you take that again, please?
Okay, I'll just take a step back. This is the problem. What we have here is that S is a number, E is a number, N is a number, D is a number, M is a number, O is a number, R is a number, E is a number. All these are numbers, such that if we subject those numbers to basic arithmetical calculation, we will get this result. So the number for SEND, the numbers SEND as one single digits, if we add them to the number MORE, we will get the number MONEY. And this is how it can be achieved, because the problem is we do not know if we add D to E, we get Y. Are we sure that D plus E produced just Y? Is it a unit number, or is there a carry? So if we added D to E and we get Y, is that the addition of D and E, is it actually Y plus 10? Because if D is 5 and E is 9, and we add them, we will get 14, I hope. So Y will be 4. So is it actually 4 or 14? We don't know. The same thing when we add N to R and we get E. Is it actually just E or E plus 10? When we add E to O, we get N. Is it actually just N? And remember, when you added D to E and got Y, if it was if it is not a unit number, if there is a carry, you must add the one that it carried to N to R to get E. You see that you are getting many, many more options. And in order to be able to solve that problem, you see that it is not a simple simultaneous equation. It is a problem in which there are alternatives, whether you carry in digit 1 to digit 2, carry from digit 2 to digit 3, carry from digit 3 to digit 4, and all that. You cannot say. And all these are options. And that's why the only way to solve the problem is to create this tree, which goes down, says that, well, there's a possibility that D on the right, the second level, D plus E equals Y plus 10. That's one possibility. Another possibility is that D plus E is just equal to Y. If D plus E is equal to Y plus 10, the lower level on the right, then it means that N plus R plus 1, that is the one that was carried, is equal to E plus 10. And all these are various possibilities. And you have to go on. And even after the last level we have here, there's one more level, which is the level of adding S to M to get O with a carry. I hope it's better. Have I explained it a little better?
Yeah.
Yes. I think that's better.
Thank you.
Yeah. Thank you, Abdullah. Thank you for that. We are getting more questions, and I'm sure they are getting more technical as well by the day. But I see a question here, Doc. that says, I want to thank the presenter for a very clear presentation. That's from Clement Odoje. I will want him to talk more about AI application to our day-to-day activities. So this is looking at it from a higher level now, a broad level. What are the examples of AI that we can point to in our daily activities?
Well, thank you very much, Mr. Odoje. Actually, no, Mr. Odoje is a Dr. Odoje. Towards the end of the program today, we'll be looking at applications. But maybe I can just say for now that the applications of artificial intelligence are myriad. There are many, many areas of traditional computing that cannot, there are many problems that traditional computing cannot solve. And when we start going deeper later on today, you see that some of the things that we think are simple problems, they are actually quite involved. And when we look at it, we find that even though they look simple, there are reasons why the computer will not be able to solve them. And we'll be surprised, are there problems that the computer cannot solve? Then that's when we now start seeing that actually human beings too, when they approach such problems, they don't approach them with brute force, they approach them intelligently. If you just be patient, towards the end of the course today in this afternoon session, towards the end of the afternoon session, we'll be looking more at applications. Thank you. I can't hear.
Excuse me. Yeah, hello. Thank you very much for that. There is also a question that says, to become an expert in AI, does one have to go back to school to study computer science or any of the related courses? If no, where can non-computer specialists like me start from to become an expert in AI?
Well, the simple answer is no. You don't have to go back to study computer science. But the Nigerian answer is yes. One of my students finished BA Linguistics from the University of Ibadan, went off to the University of Birmingham. In 18 months, she got a master's degree in computer science. In another year, she will be getting her PhD in computer science, in artificial intelligence, first degree linguistics. Of course, she was not able to do that in this country. It was not possible to get admission to any computer science program here in Nigeria. And it was then I advised her to try abroad, and she did, and she succeeded. So fundamentally, it is possible. I have friends, I have a friend, first degree theater arts from the University of Ibadan, but now works as an IT specialist in a bank in the UK. So it is possible, and part of what these kind of programs are supposed to do is to make it possible for people to be able to bring what they have and build upon it to be able to achieve more. Artificial intelligence is a multidisciplinary endeavor. You see that when we started today, I was talking more philosophically than as a computer scientist at the beginning. Then I started talking like a psychologist. Then I began talking like a cognitive scientist. And now maybe I'm beginning to talk like a computer science and the engineer that I am. So being a multidisciplinary subject, it needs input from various fields of learning. And I think the most important point I want to take away from your question is to ask the authorities, education authorities in Nigeria, to look more critically at this question, because I believe we are shortchanging ourselves as Nigerians by erecting barriers to people trying to cross from one area to the other. The simple answer to the question is yes. Whatever background you have a place in artificial intelligence, because to start with, you are intelligent yourself, so you can at least express your intelligence in ways that computers can take advantage of it. But I know that in Nigeria, it is not easy, except you go through the, maybe the industry avenue. In industry, all these things happen all the time in industry. But I don't think our educational system is sufficiently matured to handle it yet. We need to deal with that. I hope I answered the question. Dr. Adewale, you need to unmute.
Yes, thank you, Prof. Yes, thank you, Prof, for those answers. I guess we are getting the picture clearer as you speak. I would like to ask Badamosi Kazim, who has raised his hand to talk. Please make your question brief. We will be rounding up this session in the next 10 minutes because we had some delays. And please note that there will be, Dr. Adebola will continue with the presentation after a 30 minutes break. So we will continue and then have further interactions down the line. So this is not the end of but make your questions brief and let the webinar. So if you're still with us,
thank you very much.
Go on.
I've forwarded my question to question and answers section.
Oh, okay. All right, that's fine.
Thank you.
I hope we have read it.
No, you have
read
not.
it then later.
Okay, sir.
Okay, then just simply ask it now that you have the opportunity.
Thank you. I asked that, is there any relationship between neural network, machine learning, and sorry, I've forgotten the last, artificial intelligence? Yes, the topic for today.
Okay. Yes.
Okay. Thank you.
You will notice that one of the tasks that I highlighted is that we want to create machines that learn. So that is machine learning. The field of study of machine learning is the field of study that makes machine learn like human beings. Traditionally, machines don't learn. Traditionally, you just give an algorithm to the computer and the computer does exactly what it is told. But with machine learning, the computer begins to get experience. The computer encounters situations, learns from it, and is able to do better. You remember I said that learning is characterized by change, getting better at things. So that is what machine learning is. So machine learning is an aspect of computers, of artificial intelligence. Neural networks is a way of making machines learn. We'll talk a lot more about neural networks later on. Well, maybe not a lot more, but at least enough to give you some background. But for now, it suffices to say that neural network is a way of mimicking the operations of the human brain. The human brain consists of neurons, networks of neurons. What we have tried to do in computer science is to try to simulate what neurons do and also bring about a network of neurons, hence what we call neural networks. And we try to make these neural networks learn very similarly to the way that the networks of neurons in the human brain learn. So the answer to your question is that, yes, artificial intelligence subsumes machine learning, and one of the ways of making machines learn is by the use of neural networks.
Okay. Okay, thank you very much for that. Right now, we'll just take a series of questions together so that you help us treat them together. Mr. Eli Ogbemunam, please can you ask your question briefly? Also, we have Mr. Peter Sunday. Can you quickly ask your question?
Hello, good morning. This is Peter Sunday again.
Okay, go on, Mr. Peter. Yeah.
Prof, good morning, and thank you for this wonderful lectures. I want to ask, how do we differentiate between inferring an unknown from a known information and recalling from a database? In other words, when we categorize who is Abu's uncle as reasoning and intelligence, whereas Abu's uncle could actually be stored in a database for easy recalling. Thank you.
Thank you very much.
Okay.
Good question.
Thank you for that. Prof, just hold on a bit. Let's get from the others too. Yeah, that's Peter Sunday. Who else is there? Eli Ogumegudam. Are you with us? Okay. He's not speaking. Let me quickly read some questions that have come in. Okay, from Patience Usip, we have, I really want to appreciate Dr. Adegbola for this clear and explicit presentation on AI. I will want him to please drive home the point on what garbage in and filtered out is. Okay, so there's another person. Thank you, Prof, for the beautiful presentation. How can this AI be best applied in classroom teaching? How can AI be applied in classroom teaching? I think Abdullah Kawu is trying to ask, are there online courses that you can take from Nigeria on AI? I'll say that towards the end of the presentation, Esther will give a short presentation on how people can take academic degrees in AI here. There is a question from Aisha Jimo. Instead of going back to school to study computer science, can we do some professional certification? Okay. Then Abdullah Kawu asked, will the video recording be available to participants? I can answer that straight away saying yes, participants will, there will be a video link at the end of the day participants can use. Okay, so those are the questions we have. I believe I've not missed anyone. Okay, there is this one from Peter Nalue, sorry. He says, dear sir, thank you for your good presentation. Please, I want to know if cryptography problem on the last slide actually has a meaning. Please explain. Yes, the cryptography. Cryptography, yeah, the cryptography problem. Does it have meaning? Well, yeah. So now, okay, that's Mr. Ibrahim Adeyoju. Did we get your question? I didn't see your question. You wrote here. Okay, can you go on our presenter just address the questions for us. Thank you.
Okay. Okay. Thank you. Thank you. These are really nice questions that help bring out what I inadvertently skipped. The first question is, what is the difference? I'll put your question. I've forgotten the person who asked it. I can sum up your question as, what is the difference between inferring and retrieving? Because you can retrieve from a database. But what you retrieve from a database is different from what you infer. If you have a database that tells you the name of Abu's mother, you have a database that tells you the name of Abu's father, and the database also tells you the names of Abu's mother's brothers and Abu's father's brothers. You can retrieve information from that database, but you will not know who Abu's uncle is until we tell you that an uncle is a parent's brother. So far, in the database, you are still dealing with information. But to turn that information into knowledge, you need a rule that tells you how to apply the knowledge. And that is that rule that says that an uncle is a parent's brother. If you do not have that link that an uncle is a parent's brother, no matter the number of brothers, of mothers, or brothers, or fathers you have on the database, you are not able to make that inference. So that's the core of inference. And I said earlier on that part of the reason why we look into things like this, why the human being behaves that way, using rules to infer information, is to avoid having to memorize everything. So in that database, if we just attach one rule to that database, then we don't need to make a list of Abu's uncles. We can always infer who Abu's uncles are from the information about Abu's parents' brothers. That's the answer to the first one. The second question, garbage in, filtered out. Well, I was just being provocative because when computers arrived on the scene, they were seen as panacea. They were seen as tools that can solve any problem. And people made lots of noise with computers until we started having some unfortunate disasters. For example, one of the space ships that crashed just because somebody wrote a full stop instead of a comma, or funny things like that. And that was when the alarm was raised, garbage in, garbage out, that it was very, very important to sit down and consider what you are putting in the computer to be able to ensure you're getting good results. But the point I am making here is that with the development of artificial intelligence, some of the ways by which human beings have been filtering out garbage to ensure that garbage does not enter the computer, because if garbage enters the computer, you will get garbage out. With the development in artificial intelligence, we may actually have routines in the computer that is able to tell that this is garbage and then filters it out so that the computer now behaves better. So even though computer is known for garbage in, garbage out, we are hoping that artificial intelligence can actually help to reduce the garbage in, garbage out perception of the computer. That is why I used that provocative garbage in, filtered out. The next question is, are there applications of artificial intelligence in classroom teaching? Oh, of course, yes. COVID-19 has exposed us to a lot of interesting things. A niece of mine sent me a lesson that was sent to her 3-year-old son by the creche that he went to. And she asked me, is it right to really pay for this thing? Because the material was totally inappropriate. But where we are today in artificial intelligence, there are lots of things that artificial intelligence can do. You can give an 800-page book to a natural language processing software, and you tell it, I want only a 1-page summary. It will produce a 1-page summary. You can say, I want a 2-page summary. You can say, I want a 10-page summary. So this is one of the applications of artificial intelligence generally in education. Also is the fact that we are at the point now where you can give a book to the computer, give a chemistry book to the computer, and the computer will extract questions that can be asked in a test. And if the questions were answered on a computer, you can now get the computer to also mark the questions. Still, I'm talking generally in education. But when we go to classroom teaching, there's a whole plethora of levels of assistance that the computer can give to teachers. Computer can, on the one hand, provide cues. I mean, look at the way we use the PowerPoint. More and more, teachers are taking PowerPoint and using them in classrooms. But with time, and it's not, I'm not talking of the future, things that happen here already. Even within a classroom environment, you can allow your students to interact with artificial intelligence systems, and the artificial intelligence system will be able to say what exactly are the areas of weakness of your students and inform you of the need to enhance your delivery in those particular areas. The applications of artificial intelligence are myriad. The easiest way to look at all these things is to look at artificial intelligence as enhanced computing. We've had computers before. All those things that computers have done to ease the various processes we undertake, artificial intelligence is going to make it even better, and is going to make it a lot more productive and a lot more efficient. Now, are there online courses for artificial intelligence? Yes, there are. Of course, the obvious is Estel. The reason why we are doing this is to alert the world that Estel is developing a program in artificial intelligence, in management information systems, in cybersecurity, and that it's open to people from all over the world. Of course, there are other courses, but for now, our own interest is what Estel is offering the world, and I'm reliably informed that Estel authorities will be talking more about what is available on the program. The other question is, are there professional certification courses that can be taken instead of going back to the university? Of course, yes. There are very many certification courses online, even brick and mortar, Sage on Stage approach. There are various courses. What we need to realize is that artificial intelligence has become a very, very important aspect of our world today. And more opportunities are being created to bring in more people, because we can achieve a lot if we have a lot more people that know. And this is part of the objective of Estel in bringing up this program to improve the general knowledge of artificial intelligence amongst our academics, so that it can impact Nigeria's development. There are various courses you can take. This kind of thing, there are things in which you know you do. There are not things in which you carry a piece of paper and say, I am BSc this, PhD that. It's very, very much the way to go. what's the meaning of cryptography problem? If I understand the question well, cryptography is the art of hiding information. You know, it is usually said that the value of information is determined to a large extent by the ease with which a deserving recipient gets it and the difficulty with which an undeserving recipient gets it. So there are times that it is important to hide information and to make it available only to deserving recipients. So in such situations, cryptography comes as a way of hiding information. So the problem that I've shown, the A plus B equals AC, and the send plus money, send plus more equals money, are cryptographic problems because the symbols SEND, MON, and all that are actually numbers, but the numbers are hidden. So maybe, for example, it's a password. Maybe it's a password for somebody's bank account, and you want to send a messenger to take it to the owner. So if you send more money to the messenger, he doesn't know that these are numbers. So when it gets to the owner, you can tell the owner what to do to get the answer. So cryptography is the science of hiding information, encoding and decoding information in ways that it is not available to the general public. I hope these have answered the questions.
Okay. Thank you very much, Prof, for that. I know you don't mind me calling you Prof because you've explained these concepts so greatly that we're getting to see the picture more and more. A very big thank you once more for the beautiful presentations. And I see many more questions coming in, but it's not over yet. We are just finishing the first session. We're actually about 22 minutes behind or ahead. So we will break for now. Our break is just for 30 minutes and we'll be back. So I suggest by 1 o'clock, thereabout, we will come back and then continue the second and last part of the presentation. After that, we will also get opportunity to ask more questions and interact on the different aspects of artificial intelligence and how they can affect our lives and how it can become a big part of the future. So on behalf of the A-Star team, I want to say a big thank you to our panelists, especially our presenter, and then all our participants that asked questions. A big thank you. We invite you to please come back at 1 o'clock where we will continue with the seminar. Thank you very much. We'll be going off for a little while and then be coming back at 1.
Thank you.
Thank you all. Yeah. Hello. Good afternoon, everyone. Just checking up. Can you hear me?
Yes, I can hear you, Dr. Adewale. You seem to have muted my camera again.
Okay.
Yes.
Wow. Okay, can you check now if your camera can come on?
Yes. Yes, it's on.
Okay.
Yeah.
All right. Thank you very much. So welcome back, everyone, to the second and last session of this workshop. It's just a one-day seminar on artificial intelligence, garbage in, filtered out. And we've had the first session in which our speaker, Dr. Adegbola, took us through lots of different concepts of AI, artificial intelligence. And so this is the second part, and very shortly we will hand over the floor to him to continue with the second part of the presentation. It has been very enlightening because we are getting to know more about the concept of intelligence and what automated reasoning is all about, and how machine can be made seemingly to think and to learn. And I'm sure he's going to explain better for us how AI can play a significant role in our development in Africa. So I've been sharing my screen, and the screen on the notepad, you can see the URL to the Estel website. This seminar has been organized by the African Center of Excellence on Technology Enhanced Learning, Estel, and the website is where you can get more information about the center, which is all about using technology for learning. And AI also plays a crucial role in this. I can just show a bit of the website before we go on, just for a second. Okay, so if you come to the website that has been displayed, you're likely going to see something like this. So there is more information on what Estel is doing, the programs Estel offer, the short courses, resources, research, and the likes. So more of this will come in later as we go. So without wasting any further time, I'd like to hand over to our speaker, Dr. Adebola, to please proceed with the second section for the afternoon. Thank you very much, sir.
Thank you. Can you hear me?
Yes.
Yes, we can.
Thank you very much. Welcome back to the second session. And to just round up what we were talking about earlier on, because we will go further to actually engage and try to make the computer reason. The problem we dealt with, can you see my screen? Is my screen?
No.
Is my screen shared?
No.
No, it's not shared.
You need to give me the screen to share it.
Okay, just a minute.
Okay.
Are you being denied access to share?
I've got it. Yeah.
Okay, all right.
I'm not seeing my PowerPoint screen.
Maybe you need to show all windows.
Okay, sure. Okay, thank you.
Yes, sir.
Okay. So can you see now?
Yeah, we can.
Yes.
Thank you. So just to backtrack a little, we looked at the problem of A plus B equals AC. Take the A as saying that something like 1, 2, rather than A times C. we found that it cannot be A plus B equals C, because there is A in front of the C, which means we carried a number. 1 is the only number you can carry, so we came out with the idea that, okay, it must be A plus B equals C plus 1. Now, that means A is 1, if we carried 1. So if A is 1, it means 1 plus B is equal to C plus 10, which means that B is equal to C plus 9. It means, therefore, that B can only be 9 if you added 1 to it to have a carry, because if it is 8, it will not have a carry. So it means that A is 1, B is 9, and C is 0. Now, that is exactly what we want to do to get the answer to send more money. So in using search to reason in computers, in artificial intelligence, we will look at this and we follow the various combinations. We try each of them, and we see that as we go on, some of them will yield contradictions. And after having resolved the various contradictions, you now come with something like this, which then tells you that S must be 9, E is 5, N is 6, and D is 7. M is 1, O is 0, R is 8, and E is 5. And if you look at it, you find that the arithmetic is consistent, and the arrangement of the numbers are also consistent. The mathematics amongst us know that there's no way to solve this apart from considering these alternatives. And when we humans think, what we are actually doing is considering alternatives. And we will go and look at one more problem in which we have to consider alternatives. And not just 1, 2, 3, or 4 alternatives, but lots and lots and lots of alternatives. In fact, millions of alternatives. And we now find out how we actually achieve these things. Come with me. I'm sure you see some familiar faces.
Yes.
Yeah. Even presidents play. This is the game called Mancala, generally, but this comes with various names in various cultures. This is the simple board. It's a board game. You notice that each of the hole in the board has 4 seeds. One player sits each on either side of the board, picks one of the holes and sows the seed until it runs out. Well, actually, there are various rules, but the most common, or from my own opinion, the one that demands so much intelligence is the one in which you take the 4 seeds, and when it's exhausted, you stop. Now, if you get to your opponent's side and you end up on 3 or 2, you can take it, and that's how you win. And at the end of the day, when there are no more seeds to play, the person that has the most seeds wins. This is a typical situation in which you consider alternatives. On each side, there are 6 holes. At any time, you can pick any of the 6 holes. So how do you decide which one to pick? Those who are conversant with this game, they know the tricks to play. Can we teach the computer these tricks? That's the question I want us to answer. And this is what leads us to automated reasoning. The game is called Mancala. Some people call it Owari. Some call it Ayo. Some call it Ncho. Some people call it Kalokalo. There are all sorts of names. It's probably the most celebrated African board game. The seeds are sown anti-clockwise, and it's captured if you end in 2 or 3 on the opponent's side. The fact is that every move demands intelligent behavior. If you pick seeds randomly, you will be beating blue-black. Every player considers all the 6 holes before they play. And not only will they consider all the 6 holes, they consider all the 6 holes on their opponent's side. So you see that here now we are not talking about considering 1 or 2 things. We are considering many, many things. So the question is, can we get the computer to make such intelligent moves? Well, the answer is pure yes. With artificial intelligence, you can teach the computer to make these moves and beat even some of the best human beings. Just in the same way that chess, checkers, and even recently Go, which was considered one of the most complex games in the world, computers have been used to play them. And in the same way, we can write programs that incorporate artificial intelligence to play the game. So the question is, what does it take? How can we make the computer make these choices? And the simple answer is automation of reasoning. We want to teach the computer to reason, to look at the holes and determine which one is best to play at any given situation. There are 2 terms that define this problem. Problems like this. And in fact, many problems that are solved by the search approach. One is the branching factor, and 2 is the depth. The branching factor of a problem is a measure of how many options are presented at each point. When you are playing a game or when you are trying to take a decision, how many options are presented to you? That is one very important aspect of automated reasoning. What is the branching factor of the problem you are trying to solve? The second is the depth. That is, how deep would you go to get a solution? And these 2 will determine whether you can use the computer to solve the problem or not. The computer scientists amongst us, and probably mathematicians who have done work in operations research, will be conversant with the idea of combinatorial explosion. Combinatorial explosion is a situation that arises in which you are faced with a choice. You do not have the adequate information to tell whether you should go left or right. And you thought, okay, if I go left, let me find out what is at the end of left. I can then come back and take my decision. Or let me go right. If I find it's what at the right, I can come back and take my position. But when you go left, what you find is another branch. You say, okay, let me go left. You go left, you find another branch. And you keep on going like that and finding branches. Remember, you've left a series of right turns that you have not even entertained. So that is what happens when we say we engage a combinatorial explosion. The thing just keeps exploding and exploding to the extent that you might just get lost. When you are faced with a problem that features combinatorial explosion, in mathematics we say that the problem is intractable. Intractable in the sense, not that the problem does not have a solution, but that if you want to solve the problem by using pure logic, you will never get to the answer because there's so much to do that you will not be able to get to the end of the problem. That's what it means when we say a problem is intractable. Once you encounter a problem with an appreciable branching factor, an appreciable depth, you are going to encounter combinatorial explosion, and is going to end up an intractable problem. And this is the problem. This is the situation with Mancala, our ordinary, popular African board game. It presents a branching factor of 6 because at each time you have to choose between 6 holes to play. And when you play back and forth, you may go up to about a depth of 20, sometimes to a depth of 40. And with the branching factor of 6 and a depth of 40, you get a really, really bad situation of combinatorial explosion, which means basically the problem is intractable. And I will still go further to demonstrate to you that it is actually intractable. But illiterate farmers play it. You know, a farmer goes to the farm in the morning, has his first serving of pounded yam by 6:30 a.m. By 12 noon, he has made 200 ridges. Comes back home, takes a wash, sitting under a tree with palm wine, and is playing this game with his opponent. The opponent plays, he responds within seconds, even sometimes less than a second. Even children play the game, and they do well. They even beat adults sometimes, as you will see later on. So, if human beings are able to play this game, yet computers, which is supposed to be more accurate than us, which is supposed to be a lot faster than us, why then should the computer find it intractable? And how can the problem be solved? These are the issues at the core of artificial intelligence. In fact, it is when human beings hit intractability that they deploy, usually when they deploy intelligence. Let's look at the first level of the search tree of that game. Look at the box on top. It has 4, 4, 4, 4, 4, 4, and then 0 to the right, and then on the top 2, 4, 4, 4, 4. That is the state in which you start this game. That is the state in which the game normally starts. If you look at the row below, you will see that hole number 1 on the lower side now has a value of 0, and the next holes have 5, 5, 5, 5. I hope you are following this. It's important that you follow. The meaning of that is that the player has picked hole 1 and has put the 4 seeds in the 4 following holes. The second box is the second option. The player could have played the first hole, but in the second option, he could play the second hole. In this case, the first hole remains 4, the second hole becomes 0, the third, fourth, fifth, and sixth holes become 5, 5, 5, 5, because he has sown the 4 seeds from hole 2. The third hole, the third box, the same, and you see that it goes on and on like that. So from box 1, 2, 3, 4, 5, 6. So what we are saying here is that from the box on the top level, you can generate these 6 new boxes. And from each of those 6 new boxes, you can generate another set of new boxes from the other side, because it's now the turn of the other side. So the first box generated 6 boxes. Each of these 6 boxes will generate 6 boxes again, and on and on and on like that. So we now see that we have a branching factor of 6, and it will go on and on and on like that. Now, if you look carefully, you will now see this is a tree diagram. The box on top represents that first 4, 4, 4, 4, 4, 4. The one below it represents the 6 holes that were generated. The ones below that define that each of those generates 6 holes too. Now, if you look at the right hand of the diagram, you will see 0 colon 1, 1 colon 6, 2 colon 36, then on and on to 6 colon 4, 6, 6, 5, 6. What that means is that when you start at the first position, let's say it's position 0, you have only one box. At the first level, you have 6 boxes. Hence, we have the 1 colon 6. At the second level, we have 36 boxes. That's why we have 2 colon 36. And then on and on like that until you get to the 6th level where we have 6 colon 4, 6, 6, 5, 6. What that means is that as the game goes deeper, there are lots and lots and lots more of different options to consider. If you have any flair for mathematics, you will notice that if we look at the relationship between the numbers 0, 1, 1, 6, 2, 36, 6, 4, 6, 6, 5, 6, you will notice that there's a relationship with the level and the number of boxes, or let me call them nodes. In computer science, we refer to them as nodes. So what we are saying here is, if we want a computer to determine which hole to play at any given time, he will consider the first 6 holes. He can look around and find that one of the holes will lead to a capture of seeds, and he might rush ahead and play that. Now, if you have ever played any game, you know that sometimes your opponent will draw you out to go and capture what you should not capture. So, which means, therefore, you should not consider just the 6 holes. You should also consider the 36 different holes with which your opponent can respond. Now, for the human being, that is a lot to put in one head at one time. But for the computer, it's a piece of cake. So let's continue. Now, a little bit of mathematics. After all, it's a PhD course. Given a problem with a branching factor of B and a depth of D, each level generates B to power D nodes. That I have shown earlier on. Because if you look back here, you see that B to power 0 is 1. Anything to power 0 is 1. If the branching factor is 6, 6 to power 1 is 6. 6 to power 2 is 36, and on like that. So that's what we have come up with there. So if at each level B to power D nodes are generated, it means at any given depth, the total number of nodes that will have been generated must be equal to the number of nodes generated at each level, all added together, which is what we have there, which is at the depth of D, if we are representing the accumulated number of nodes by n sub D, then m sub D must be equal to B to power 0, that is for the first level, plus the nodes at the level 1, B to power 1, nodes at level 2, B to power 2, and on and on and on, adding all of them up to b to power d. So we get that expression. Now the expression does make sense, but it's not very easy to deal with. And mathematicians have taught us that we can rationalize it. We can rationalize the expression by multiplying each side by 1 minus b. And if we do, we'll get that nd into 1 minus b is equal to b to power 0 plus b to power 1 plus b to power 2 all the way to b to power d. Now minus b to power 1 minus b to power 2 minus b to, all the way to b to power d, and then b to power d plus 1. Because we first of all multiply b to power 0 all the way to b to power d with 1, and then we multiply by minus b. Now we now see that there are two b to power 1s, there are two b to power 2s, there are two b to power 3s, and on and on to b to power d. And one is positive, the other is negative, so they cancel out. So if all b's cancel out, we then end up with nd, n sub d, multiplied by 1 minus b is equal to b to power 0 minus b to power d plus 1. I hope you are following me. We know that anything raised to power 0 is 1. So we can say it is n sub d times 1 minus b is equal to 1 minus b to power d plus 1. If I've lost you, don't worry, you'll catch up with me 1 minute. Now, if we divide both sides by 1 minus b, we then end up with this neat closed form expression, which says the total number of nodes at any depth of d is equal to 1 minus b to power d plus 1 over 1 minus b. We will now use that knowledge to find out the actual number of nodes given the branching factor of 6 for our game Mancala and to any given depth. So this is what we get. I hope you can see the screen. It's quite a lot of numbers. On the first column, we have 1, 2, 3, 4, 5, 6, 7, all the way down to about 23. On the next column, we have the branching factor at the very top, which is 6. And then down we have the number of nodes for any given depth. At the depth of 0, the first one, we have 1. Second, 7. Because we have a branching factor of 6, the first node will generate 6 nodes. So if we add the first node to the 6 nodes generated at that level, we have a total of 7 nodes. Then the next level will generate 36 nodes, add 1 to 7, 8, add 36, we get 43, and on and on and on like that. So you now see that by the time we get to the depth of 23, we have 1.57 times 10 to power 17. That means we are going to have 1 and 17 zeros following it. That is a huge number. We want to try to find out how long it will take a computer to consider all these nodes. So on the third column, we arbitrarily determine that we have a computer that takes 0.00001 seconds to deal with one option. So we can now see how many seconds it will take the computer to deal with the total number of nodes at level 1. It takes 0.00001 seconds. Really fast. About 1,000 times faster than 1 second. To deal with node 2, to deal with level 2, it will take about 0.00007 seconds. And on and on and on like that. That's the time it will take in seconds. Now, we human beings don't work much in seconds. It's easier to work in some more civilized units of time. So let us convert the seconds into minutes by dividing by 60. That is what you see on the 1, 2, 3, 4th column. On the 5th column, we divide by 60 again to get the number of hours. Remember that 60 minutes make 1 hour, 60 seconds make 1 minute. Then on the next column, we divide by 24 to find the number of days that it will take. The next column, we divide by 365, approximately number of days in a year, to find how many years it will take. And on the last column, we divide by 1,000 to find how many millennia it will take to solve the problem. Remember, what we are talking about here is that our game has a bragging factor of 6, and we can go to, well, at least we have traced it to depth 23 here. On the spreadsheet from which I copied this, it went to about depth 50. You can imagine how easy that is. If you look at the minutes column, you find that by the time you get to depth 10, it is beginning to take 2 minutes. That is, you consider my side, consider my opponent's side, my side again, opponent side, my side, opponent, up to a level of 10, 5 on each side. To consider that with a computer that takes 0.00001 seconds to consider each option, it will take about 2 minutes. It's not too bad. When you watch people play the game, sometimes they actually pause that long to consider things. But if you go to the next level, you find that to go from level 10, level depth of 10 to depth of 11, it has increased from 2 minutes to 12 minutes. Anybody who takes 12 minutes to make a move, people will laugh at him. They will so ridicule him that he will abandon the game. Not to talk of level 12, which is now giving us 72 minutes. Let's leave minutes alone. Let's go to hours. When you start tracing, you find that by the time you get to level 12, it's beginning to take up to 1 hour already. That is grotesque. Let's go to days. You go down, by the time you get to level 14, it is taking about 2 days. That means it takes about 2 days to consider all the various options and tell you this is the one to take. If we go to the next level, which is level 15, it's going to take you about 11 days. Let's go to years. Let's trace down. By the time we get to level 17, we see it's going to take about 1 year. Imagine you are playing a game. You have made a move, and you're asking the computer to respond. And this computer that is so fast that it considers each option in 0.00001 seconds is taking 1 year to come back with an answer. Go to level 18, 6 years. Go to level 19, 38 years. By the time you get to level 20, it is taking 2 centuries. So when you start the game, your great-grandson will come out and say, yes, my great-grandfather was right. Because you will have gone, your children will have gone, it remains your great-grandchildren to see the end of the game. So the implication here is that given what we have analyzed here, the computer ordinarily cannot play this game because the demand of time that it needs is inordinate. I hope you are following me.
Yes.
Thank you. Most such problems manifest combinatorial explosion. Once you are searching for something you don't know where to find, it features combinatorial explosion. It's like dropping a pin on a football field, and the pin is so important, maybe it's made of gold, and you have to find it. So you've got a problem with combinatorial explosion in your hand. Because if you go to the top left corner of the field, you are not going to trace from the top left corner to the right corner, go back again, and go all the way down like that. When an algorithm manifests combinatorial explosion, the algorithm will demand inordinate resources to run. We have seen already that the kind of time resources that this algorithm is asking of us is inordinate. It doesn't make sense. You are playing a game, you are now finding out by virtue of the number of options that the computer is going to consider, that even if the computer is so fast that it can consider one option in 0.00001 seconds, it will still need about 1 year to get to a depth of about 18. Many years ago, when in computer science, problems like this were faced, computer scientists felt, well, it's just a matter of time. One day computers will get so fast, they'll be able to solve them. And then they say, well, we can even put many computers together to solve the problem. So connect many computers and divide the work over many computers. But what we find is that in the observable universe, there are only 10 to the power 80 atoms. I need you to really get that point. There are only, well, I said only, well, for the for what we are talking about in terms of the number of options the computer has presented us, or the game has presented the computer. There are 10 to the power 80 atoms in the observable universe. So the question therefore is that even if we use every atom in the observable universe as a processor, which is not even possible, we can still not solve this kind of problems that manifest combinatorial explosion. So we conclude that most such problems, once you have a fair branching factor, and remember, our branching factor is not 1,000, it was only 6, and a depth of about 18, and see what has happened. So most problems that have, most such problems are intractable if we want to use brute force algorithms. That is, you just want to use the sheer force, the sheer power, the sheer speed and size of memory of the computer to solve the problem. So the question we need to ask, therefore, is if this simple branching factor of 6, depth of 18 is overwhelming a computer to the extent that if you start the game, it's your great-grandchildren that will finish it in their old age. But how does the illiterate farmer do this? Probably that farmer is not as illiterate as we thought. But at least even whatever it is, can we find out what the illiterate farmer does to be able to achieve the results that a computer cannot achieve? The illiterate farmer achieves that result in about a second or two, what the computer is going to take 300 years, 3 centuries to achieve. So, and that is why I said in the morning that in artificial intelligence, we take our cue from human beings. And so for the first thing we did in trying to solve this problem is to sit down and look at human players, interview them. Why did you make that move? Why didn't you do this? Why didn't you do that? And you will now find that when you look at what the human being is doing, we might be able to find some of the tricks we might play to make the problem more easily solvable with computers. The problem here is, are we making a blind search? That is, we are just searching the totality of the tree. Or are we engaging an informed search? Is there any way that we can know that this branch is not going to be useful, so we should not waste time searching it? That is the issue on the table. Because human beings do not consider each hole at each level all the way to about depth 18. The human being doesn't have that capacity, neither in speed nor in memory capacity. So what we are finding out now is that we cannot solve the problem by undertaking brute force search. That is, searching by just the fact that the computer is powerful. The power of the computer is not enough to solve this kind of problems. So we need to now find out what human beings do to get better. I mean, look at these two ladies. They are playing to the astonishment of the whole court. I mean, they must be really, really brilliant and intelligent ladies to be able to do that, because every move in this game demands intelligence. And even though this is a still picture, if it were a video, we'll have seen that the ladies are not waiting for 2-3 minutes to make their moves. So they are able to make the moves within seconds. So what are they doing? How is it that they can do what computers cannot do? Or what about this boy? Now, this is even the crudest way of playing this game. But you will spare me for the next 2 minutes to watch this game. Please, just watch keenly. I will try to give some commentary. But watch keenly what that little boy is going to do to that old man challenging him to the game. The little boy plays. The man contemplates it and makes his move. And the boy responds immediately and picks from the man's side. You see, they are playing immediately. They are not thinking, waiting to think. Look at the assurance with which that little boy is putting the seeds in the hole. You can see that he knows what he's doing ahead of time. Well, the man makes his move. With assurance, the boy makes his move immediately. He didn't stop to think. Another move. Without hesitation, he accumulates, continues, accumulates again. Now he has picked a set of seeds. He's waiting for his opponent to move. Because the opponent didn't move, now he has played that pile. And see what happens. He collects all that. So did that boy anticipate that? He has thought ahead of time? And the game continues. Without hesitation, he plays. And there he goes again. So he's been planning all that. And there goes the boy again. So, look at this little boy. He is able to achieve what the computer is not able to achieve. Earlier on, somebody asked whether it is really true that calculation does not entail intelligence. So that's the end of the game. The boy won. You can see how the boy played. Now, there is calculation in all this, and the computer calculates, but the calculation has not solved the problem for the computer. So what is it that human beings do that makes the human being outperform the computer? The human being use what we call heuristics. What are heuristics? Heuristics are common sense rules that may not guarantee optimal solutions all the time, but offer acceptable solutions most of the time. If you are going to sit and consider every possible option from beginning to about depth 18, you will need 3 centuries. So, but is there any information that you can get that you can use to determine whether I should play this or not that? These are the things we refer to as heuristics. We say that heuristics may not guarantee optimal solution all the time, but they offer acceptable solutions most of the time. It is because heuristics do not guarantee optimal solutions all the time that you never determine the winner in a game by just one game. You allow them to play a number of games, one against the other. And then after about 5, 6, 7, maybe 10 games, you decide who is better. Because both of them are using heuristics, which does not guarantee optimality, but it guarantees acceptable solutions. Heuristics are mental shortcuts that ease the cognitive load of decision making. A lot of times we have decisions that we make, and from now on, whenever you want to make a decision, if you sit down and consider your options carefully, you will see that your options are many, many more than the ones you're actually considering, because you have used heuristics to remove some of the options. They are mental shortcuts. They ease the cognitive load of decision making. They are rules of thumb. They are educated guesses based on experience. So what we are saying here is that after playing the game a number of times, you develop some kind of some kind of feelings. You begin to feel without even being able to say for sure that this will win, but say no, this will win. So that is the kind of things human beings do. If you go to a restaurant and they present you a menu, expensive restaurant, lots of interesting meal combinations, and rather than sitting down to read the menu in details to determine some exotic food you want to eat, you just order a meal you enjoyed in the past. You have just applied heuristics because it comes from experience. Rather than sit down and consider bit by bit and get a very, very good, interesting, exotic plate of food, you have used your experience because you don't want to spend inordinate time resources considering the various options before you. So what we have said so far is that when human beings think, what they are doing is considering options, which is what we refer to as reasoning. We also want to make computers consider options. Our first attempt has kind of been not too successful because we now find that the options are so many that if we set the computer to it, it might take 3 centuries. So we are now finding out that we need to find the appropriate heuristics to use to reduce the time needed. When we use heuristics in search, what we normally do is that we apply the heuristics to various branches of our search tree, and we rank the alternative branch at the various alternatives based on available information. We put the best branch ahead. Then we now cannot cut down the branches that we perceive to be unproductive, so that we don't spend important time examining these branches. And what we must say here is that for every branch you cut down, you are saving a lot, because if we had the opportunity to just change our branching factor in the spreadsheet I showed you earlier on, from 6 to 5, you see how much time would have been saved. Even though even if we increase the speed of the computer, it will still not solve the problem. But if we can reduce the branching factor, a lot more happens. So in heuristics, our target is to cut down branches that are perceived to be unproductive, or to examine the more productive branches first. So if we examine the more productive branches first and they give us good solutions, then we can afford to forget the unproductive branches. But sometimes we actually go ahead and cut down those branches, even though that means that if we change our mind in future, we might have lost something. But neither here nor there, because we cannot search everything anymore. Now, there are various ways by which we can search through trees in artificial intelligence. We have what we call the BSF, which stands for Breadth First Search. That is, we take an option and we look at all the options at the same level across the breadth of the space. The alternative is to do a depth first search. That is, we'll go down, look down at the options, Sometimes we can do a best first search, another BFS, but best first search, in which we order the options and pick the best. Then we have what we call hill climbing, in which we just go along the lines of best options, what human beings normally call the line of least resistance. Hill climbing is like if you are on, let's say somebody is blind and is trying to climb a hill. He takes a step to the north, take a step to the south, take a step to the east, take a step to the west, and finds out which of them is higher than the existing position. And he climbs to that higher point. And then does the same thing again. Takes steps. If he has any higher point, he takes it. If the blind man continues doing that, the blind man is guaranteed to get to the top of the hill, because he is taking the incremental ascension. And that is what we call hill climbing. And we do that also in artificial intelligence. Another method of searching is what we call branch and bound. If you register for the STL course, you will get a lot more of that. This is just to tell you the kind of things you will learn. We don't have time to go into all that today. Also, we have what we call the A-star algorithm, another means by which we can parsimoniously search trees. When we have a problem of adversarial search is when you are searching for options and you have somebody who is an adversary, like in a game, you are trying to make a move. You are anticipating that if I do this, this will happen later, but you don't know what your opponent has in mind. So when you make a move, your opponent spoils the move. You make another move, he spoils it. That is what we mean by adversarial search. So when you are trying to search in an adversarial situation, you use what we call the minimax algorithm. Then we have alpha beta pruning, which are methods of cutting down, pruning some of the leaves of the tree. All these just are in a bid to achieve parsimonious search, the efficient search that will not take you 300 years, search that probably will take you a few seconds or even less than a second. And these all involve elements of intelligent behavior. The things that we do to reduce the number of options we have to consider at any given time always involves intelligence. It is intelligent behavior. So let's have it in mind that as we now try to find ways around these problems, it is these ways that we refer to as intelligent behavior. We will leave automated reasoning there. Let us now look at machines that learn. That's why I say here machine goes to school. The machine is now going to learn. You see, human beings have been making tools for about 2 million years. We've found tools that are more than 2 million years old. They are made based on what archaeologists, anthropologists, and people who study human societies refer to as the Oldovan tradition. The Oldovan tradition of making tools is a tradition in which every tool that is made is dedicated to a particular use. So when you make, for example, if you make a cutlass, you are instructing the person you sell it to that this is supposed to be used to cut. If you make a fork, you are also already putting instructions to it that when you buy this thing, use it as an eating utensil. So the Oldovan tradition of tool making is one in which tools are made for specific purposes. In which case, it is the maker of a tool that determines what the tool is supposed to be used for, not the user of the tool. The maker of the tool determines this is what this tool is supposed to be used for. And that is the tradition in which we have been making tools until maybe the last 50, say, give or take 100 years, when the computer came in. The computer is a general purpose hardware that is controlled by software. If somebody makes a computer, there is no way the person can predict what the computer is going to be used for. When I bought my computer, the person that made it had no way of finding out that I'm going to be using it to present a webinar. So it is, the use to which it will be put is determined by the software I put on it. So this is a departure from the Oldovan tradition of dedicated tools. For the first time in history, when computers came, we finally made a tool in which the maker of the tool cannot determine what it will be used for, because it is a general purpose hardware that can be controlled by software. And we went on and on and on and on with this general purpose hardware until recently. We use, for every use we want to put the computer to, we bring out a specific software that will make that thing happen. But of recent, we upgraded the use of computers to the application of a general purpose software controlled by data. This is one of the most fundamental differences between traditional use of computers and its use in artificial intelligence. In artificial intelligence, we have a general purpose software which is controlled by data. I said earlier on that there are about 3 or 4, there will be about 3 groups of software. We have search algorithms, we have logic algorithms, and we have learning algorithms. Now that the computer is able to learn, we are now finding that the same learning algorithm can be used for the computer to learn very many things. And this is a kind of mimicry of the human brain. We are finding out ways by which we can make the computer, we can construct the computer like after the structure of the human brain, such that we don't need to change the software in the computer when we want to learn something different. The same software that learns one thing can learn a totally unconnected thing. So this is a mimicry of how the human brain works. And this is what we are trying to do in artificial intelligence. There are 3 main types of learning, 2 of which have been used extensively, the third which has recently become quite popular, but the first 2 have been used over a long time. The first 2 are what we refer to as supervised machine learning and unsupervised machine learning. Supervised machine learning is usually referred to as classification, while unsupervised machine learning is referred to as clustering. What do we mean by supervision here? What we mean by supervision is that before we present situations to a computer to learn from, a human being has already labeled the learning examples, suggesting what should be done. So this is what we mean, because a human being has supervised the process of learning. A human being has put some examples into classes. So the classification now is based on what human beings have recommended. The computer then learns from there. There are situations in which we do not have examples by human beings. In such cases, we used unsupervised learning, in which case we have not labeled any data, but once we present the data to the computer is able to deduce that some elements of data are clustered together while others are clustered together. You may have 2 clusters, you may have 3 clusters, you may have 4 clusters, you might have various number of clusters. And if you have ever encountered artificial intelligence in any substantial level, if you've ever heard of K-means, that the K is just saying the number of clusters there. So these are the 2 primary methods of machine learning. Let me reiterate a little. You know, I said earlier on, probably in the morning or towards the afternoon, that the whole thing we refer to as learning is trying to put objects, circumstances, the things that we experience into classes, into categories. Because if we can put them into categories, we then don't need to remember what each one of them does. Once we know what the category does, once we know what the class does, and we have appropriately assigned an object to a particular class, we can assume that it will behave according to the class. The most basic element that we use to mimic the human brain is what we call the perceptron. The perceptron. At the top there, we have a biological neuron. This is how the basic building blocks of the human brain or the brain of any animal looks. What determines whether it's human or not in terms of brain is the number and the complexity in the connections. So this is one unit of a biological neuron. On the lower level is an example of an artificial neuron. You will see some kind of similarities. You see that we have inputs into the system, x1, x2, and all that, into then with some W's, then it goes into a circle that sums, and then it goes to another circle that gives a kind of a step situation. So these are two examples of the biological neuron, and we have made an artificial neuron to mimic the biological neuron. How do we realize the perceptron, an artificial neuron? What we do is that we look at the situation where we have given a set of n features. We have x0, x1, x2, x3, all the way to n. And we have another set of binary labels. Binary in the sense that it's either yes or no, good or bad, true or false. To put some flesh to this, let us say x0, x1, x2, x3, and all that represent the features that a banker uses to determine whether to give somebody a loan. X0 may be, let's leave X0. X1 may be his annual, his monthly income. X2 may be his monthly expenditure. X3 may be his number of children. X4 may be his number of wives. All the things that will affect the capacity of the person to pay back are listed. Now, in any bank, you will have examples of these features, and you will have examples of people with various characteristics that have been given loans before. Some have paid, some have not paid. So what we are trying to do here is to use the perceptron to determine who will pay back their loan based on the various features x1, x2, x3, and on and on like that. So what we are trying to do is, if you look at the 1, 2, 3, fourth line, we are looking for a situation in which y, that is the output, is equal to W0, X0, W1, X1, W2, X2, W3, X3, all the way to Wn, Xn. Where did the W's come from? The W we refer to as weights. Each of these X's have their value. For example, somebody's monthly income, somebody's monthly expenditure. Well, number of children. Does it really make sense to add number of children to monthly expenditure? What do you get? So what happens is that when we multiply number of children by W something, multiply monthly expenditure by W something, there is a way by which we will get the appropriate W that will make the number of children have about the same order of value in determining whether the loan should be given or not. So what we are going to do is that we are going to try each examples of people who have taken loans and who have paid back, and we want to see whether the Y that we get will be positive or negative, depending on the X's we put in, which the bank have in their archives, and W's which we'll try. We have to change the W's until the expression represents the historical information in the bank. And what really happens is that this model learns the appropriate weight that aligns the attributes to the appropriate labels, to the appropriate Y's. So we want a set of W's for which all those who paid back their bank loans were said to be positive, and all those who didn't pay back their bank loans were found to be negative in the Y. This is basically what we do. The labeling, the fact that we have these Y's that say this one paid, this one did not pay, is what constitutes the supervision. And the whole purpose, the process of learning, is finding the appropriate W's that will make the data consistent. I hope I'm getting some following. Now, sometimes you might find that one neuron is not able to solve the problem you have at hand. And that is why we will have to put more than one neuron. We'll build the neurons into a network of neurons, which is what we refer to as neural networks. So we can build many individual perceptrons as single neurons into a network of neurons. And we can have several layers of neurons, because some of the problem might be so complex that cannot be solved by one layer of neuron. We have several layers of the neural network, and we train all those layers by what we call back propagation. What do we mean by back propagation? We will put the input in, we'll apply the input, we go and look at the output, we compare the output to what the labels say, what history tells us. Did this person pay back his loan? No, he didn't pay back. Yet the neural network has said positive. So we start adjusting the W from outside back to from the output back into the input. That's why we call it back propagation. We propagate the errors, we distribute it over the various neurons until we get it right. So that is neural. Somebody asked about neural networks earlier on. A neural network is just a collection of single perceptrons to be able to be used to solve complex problems. We have multi-layered neural networks. You can see here the neural network that we have an input layer, which we call 1. You have input 1, input 2, all the way down to input n. You have a set of 3 hidden layers, H1, H2, H3, and you have an output layer giving output 1 and output 2. With this, we put in outputs, inputs, 1, 2, 3. Let's say input 1 is monthly income, input 2, monthly expenditure, input 3, number of children, and on like that. Then input 1 and 2 or to n can then now say whether the man deserves the loan or not. With this number of inputs here, well, I mean, we could have had a yes-no input like we had in the perceptron. But sometimes the answer for the request for a loan may not be a simple yes-no. It may be, we cannot give you what you're asking for, but we can give you this. Is it useful to you? So with the various output here, output 1, output 2, all the way to output n, it can be used to determine the appropriate type of loan for the person to get. Now, what we find is that this back propagation does not work very well. It suffers from a problem described as vanishing gradient. What vanishing gradient is part of what we shall be spending our time learning when you apply for this program in ASTEL. But for now, we just want to give you a rough idea of what you should expect. So because of the problem of vanishing gradient, a set of neural networks referred to as deep neural networks have been developed, which allow us to create neural networks with several layers without the problem of vanishing gradients. Some of the most popular solutions to this problem of vanishing gradients, which have helped to achieve deep learning, are autoencoders. We'll explain a little what they mean. convolutional neural networks, recurrent neural networks. Autoencoders help to automatically encode information in smaller forms. Let's say you have a set of a phenomenon that is represented by 12 inputs. You might be able to squash those 12 inputs down to 2 inputs if you use an autoencoder. And it's just a way of shrinking the input that you apply to a system. For those who may know about, I've forgotten now. Anyway, autoencoders, they shrink. They try to shrink information, still retaining the vitality of the information. Convolutional neural networks, they look at things from the point of view that human beings see shapes, and then they try to create shapes out of data. And recurrent neural network, they know that there are certain elements of data that are sequential, that what happens now depends on what happened before. For example, you look at the train of values of Naira compared to the dollar, the foreign exchange, because what the Naira is worth today depends to a large extent on what it was worth yesterday. So in order to be able to get that chain of values, we look at recurrent neural networks. This is a typical autoencoder. You put in data, it has only one layer, and you put the same number of inputs as there are outputs, but you reduce the hidden layer. The hidden layer may have 2, the input layer may have many. Now what we try to do is to ensure to play around with the weights such that the input of the autoencoder is the same as much as possible as the output of the autoencoder. So if that works, it then means we have managed to represent the input that has many, an input with many elements to one with a smaller number of elements. Convolutional neural networks, we have a set of pixels representing 2. The convolutional neural network does not look at it as individual pixels, but it looks at it as a pattern of pixels, looks at it as curves, and is able to get information from there. Recurrent neural networks, that's the one I said that is a kind of neural network that stores historical information. The information you have now still carries some past information. All these are very, very important aspects of data processing that we have found, and neural networks have been developed for all of them. Now, all we have talked about so far are concern supervised and unsupervised learning. But it is not all learning that is supervised or unsupervised. There are various other types of learning that are not supervised. For example, learning to ride a bicycle is neither supervised nor unsupervised. When somebody learns to ride a bicycle, you may be tempted to think he's supervised because there's somebody holding and saying, do this, do that. But the person who is saying, do this, do that, really is leaving the person riding the bicycle to his devices. It is when the person wants to fall that he runs there. The person doesn't say, press the pedal with so much and then lift your leg. No, it just says, do it. The person now starts pressing the pedal. When he presses the pedal in the wrong way, he falls, and we say he is punished. When he presses the pedal the right way, he's moving, and we say he is rewarded. So with time, the punishment and the reward become information that the person is using to determine how to ride. So the reinforcement learning is learning by...
We are moving towards where we'll need you to start rounding up. So.
Okay, so I'm almost there too. Yeah. It's the behavioral, Reinforcement learning is behavioral conditioning. You are conditioning your behavior, and it is based on temporal credit assignment. What temporal credit assignment means is that when you did, the credit does not come at the point at which you did the right thing. You know, for example, you are playing that game. You have made a move. It is not immediately that you get the reward. So sometimes the reward is delayed. To make matters worse, all this happens in a noisy environment where things are not easily predictable. I'll now start moving fast. Now, I titled this presentation, Garbage In, Filtered Out. Now I'm questioning my title. Is it really true that we can filter out garbage? Well, like I said earlier on, at the beginning of computers, they were seen as a panacea. Soon their limitations start coming, and came the stern warning, garbage in, garbage out. Be careful. If you put garbage in, you get garbage out. The general purpose hardware has given us problem of garbage in, garbage out. Will the general purpose software also do the same? You might have been hearing about algorithm bias. Algorithm bias is what happens when an artificial intelligence system does things in a way that favors some people above others. In order to address algorithm bias, there is a need to generate and accumulate data. Part of the data, we said that it is data that controls this general purpose software. Now, a lot of the circumstances that we use artificial intelligence for, Africans are not generating enough data. In my own field, for example, which is natural language processing, very, very few African languages generate written text daily and accumulated. So this is a disadvantage. It behoves of us as academics in Africa to address that problem. We'll see the meaning of algorithm bias. It's down to us to do things that will filter out the garbage in the data. The last statement there says that none of Google's grandmas look like mine. If you ever go to Google and Google grandma, the kind you ought to see is that like this. This is an example of grandma on Google. None of them look like my grandmother. This is another page. None looks like my grandmother. I looked at 7 pages like this, full of grandmothers, Google's grandmothers. None look like mine. When I got to this one, I saw 70-year-old grandma tasered by police. This lady here, a 70-year-old woman, was tasered by police. They used the electric shock. Excuse me. They used electric shock on her. And that was the first picture of a black grandma on Google's grandma, an unfortunate grandma. Well, all hope was not lost, because when I went ahead more, I now found this 77-year-old grandma that graduated from University of Lagos. So maybe we thank God for little, for little things. But the point I'm making here is that if we actually expect artificial intelligence to put us in good stead, we have to generate data. The reason why Google's grandma does not look like mine is because we Africans have not put pictures of grandmas on the internet. The way Google does it, Google didn't go to ask anybody to put grandma. Google just searches for any text that says grandma and looks for the attached photograph. For example, this grammar here. The caption is 77-year-old grammar graduates from UNILAG. And Google picked the grammar there and presented the picture. So if we do not put data that will put Africa in good stead of artificial intelligence, we will not benefit optimally from developments in artificial intelligence. This algorithmic bias goes beyond grammar. There's this case of the racist soap dispenser. If a white man puts his hand under the soap dispenser, the soap will dispense. But if a black man puts his hand there, it will not dispense. Because when the soap dispenser was trained, it was trained with white hands. We need to generate data to correct such. There was an image recognition software that labeled 2 black people as chimpanzees because there's not enough data to train to distinguish between human beings and chimpanzees. That's another issue in algorithm bias. There was a Nikon blink detection camera that avoids when you click. If your eyes are not open wide, it will not take the photograph. It did not work for many Asians because Asians don't have their eyes as wide open as Caucasians. Because the camera was trained on Caucasians, it did not succeed with Asians, despite the fact that Nikon is an Asian company, Japanese company for that matter. Of course, you know that speech recognition software will struggle with your accent. We need to supply data to make our accent work. We have a responsibility to offer the data to correct all these things. What are the applications of artificial intelligence? My own special area in artificial intelligence is natural language processing. My work is to make computers usable in African languages. So you might find that I have algorithmic bias for language applications. Automatic speech recognition, ASR, that is you speak your language, Yoruba, Birom, Fulfulde, Tiv, whatever, to the computer, and the computer writes it in the standard orthography of your language. Or you send a text to somebody, TTS synthesis, and the computer, your phone reads it to the person. So if you send a text to your grandmother doesn't need to go and give the phone to the child of a neighbor to read it for her, just in case you are just gossiping the neighbor. Machine translation, translating from one language to the other. Who better needs machine translation than a Nigerian? If we can translate between the various languages in Nigeria, maybe, just maybe, we'll have much better understanding. And all these have to do with the peculiarities of our language. Our language are tone languages, and there are various things that make it necessary for us to put in effort. In agriculture, you know that in agriculture, tree crops in the temperate part of the world, in Europe, are not as high as tree crops in the tropics. So a lot of agricultural equipment cannot deal with some of our tree crops. There is a need to apply artificial intelligence to agricultural equipment to make them operate more efficiently. In business, customer relationship management, analyzing what your customers buy, analyzing their buying habit, and seeking to associate them, and seeking to satisfy them. In retail, virtual retail assistants. Overall, we need to provide data that will make these things work for us. Because these days we talk of big data, and that is data that is accumulated, not data that you went to or gather. Data that is accumulated in the everyday ordinary use of the devices. All these, we have great responsibilities. Now, the SLMSC and PhD in artificial intelligence seeks to empower Africans to take much better advantage of modern ICTs as productivity enhancement in our development efforts. There's a need for us to undertake relevant research to appropriate artificial intelligence for our peculiar development needs in Africa. At the Estelle MSc PhD, you will get basic tools, basic knowledge tools, such as probability and statistics, linear algebra, AI theory, and learn a lot of programming skills, Python, and various AI libraries of Python, such as NumPy, TensorFlow, Panda, and lots of application. So you have a lot to benefit by coming for the Estelle MSc and PhD programs in artificial intelligence. Thank you very much.
Okay, is Dr. Adeole there? Would you
Yes, I'm here. Thank you very much, Dr. Adebola, for that very interesting and informative session.
Thank you.
Actually, I felt like I've started taking the course already. So much to learn. Our AI is very wide and very nice. Thank you so much. We appreciate that time you've given and the very gentle way you presented this seminar. So we've come to the point where we can interact. I know that for many of us still online, definitely we are in the field, or we are so much interested in the field and want to go further on how to learn. And on the screen already, there are information for us. So, but if we have any question, or if there are questions, just raise your hand with the feature as we did in the morning. And then secondly, we can also type the questions on the chat messages that we have. So already, I think some questions have started coming in. Let me quickly take the one I've seen now. There is a question from Ibrahim Abdullahi. He says, thank you very much, sir. Sir, do you consider any rule-based algorithm like Java Expert System Shell as an intelligently based system, or it must qualify other elements of characteristics, or it must qualify other elements of characteristics of an intelligent system? Well, I guess the question is whether the rule-based or any general rule-based algorithm, does it qualify as an intelligent-based system? So that's let me see how many we can take at once, and then we'll take them together, sir. So we have Clement Odoje, who says, we thank our presenter for this great job. With this conclusion, I think there is need to begin to gather or work on big data, especially on our local content. Okay, I think this is a general comment about putting in more data out there so as to limit the biases that are existent. Okay, so these are the two comments we have. Okay, there are some attendees that have raised up their hands. Let me pick one first, and then you can take the three comments together first. So I have a Gadzama, Emmanuel Haman Gadzama. If you're on now, you can speak. Emmanuel Gadzama. Okay, there is also Pet Wilson Olatunde. Okay, Pet Wilson Olatunde, if you are with us, you can speak.
Good afternoon, everyone.
Good afternoon.
Yeah, my name is Petrus Alatunde. First and foremost, I would like to appreciate the organizers of this seminar and to also appreciate the presenter, Dr. Agbola. Your presentation was very expository. Thank you very much. Actually, my question is this. For a person that's coming from an information technology field, what best path can one take if he wants to go into artificial intelligence?
Okay, thank you for that question. What best path to take for to get into AI coming from an IT background? Okay, so I'll allow Dr. Adegbola to please respond to these questions, and then we'll take more. Yeah.
Thank you. First question, very interesting question. A rule-based algorithm is an AI system, is an intelligent system, because of the rules there. Now, in the morning, I, in passing, talked about the data knowledge continuum. You start from data, which are just raw facts and figures. You process the data into information. Then you apply rules to the information to become knowledge. So when you are talking about knowledge-based, rule-based systems, you are really talking about knowledge-based systems. And this is the fundamental of what we call expert systems. Expert systems evolved out of one of the early frustrations of artificial intelligence researchers. When we were doing lots and lots and lots of work, we were not able to get concrete solutions to important problems. Then it was discovered that we could look at narrow domains, narrow lucrative domains, domains in which you have a lot at stake. For example, in the oil industry, some of the early expert systems were used in the oil industry, the prospector and such expert systems. So what they did then was to talk to human experts, extract the rules that human experts use to solve problems, and program these rules into rule-based systems on computers. So a rule-based system, basically and fundamentally, is a system in AI. Now, with the recent development, with the recent success of machine learning, the emphasis and the attention on rule-based system has kind of fallen. But I, as a scholar in information science, I take the position that the lull in the popularity of rule-based systems is going to be temporary. Why do I say so? Data-driven learning, which is what machine learning, present machine learning is based on, is very, very effective. In fact, it is the way children learn. Children learn by being subsumed in data. Language, for example. Nobody goes to school to learn language. You just live within a language community and you pick up the language. That is data-driven learning. But when somebody goes to the university to study for a PhD in his mother tongue, it is rules that you will be taught. It is rules that you will evolve. To get your PhD, you are going to be telling us rules. So rule-based systems are systems that are used by experts. Data-driven systems are systems that are used by the hoi polloi. So rule-based systems are still going to come back with a bite. They are going to become very, very important. I believe that firmly. So in a nutshell, yes, rule-based systems, whatever shells you use for them, maybe Java, maybe Python, even if you use Fortran, and people still use them, it is still an artificial intelligence system. Dr. Odeje, yes, thank you. It is very, very important that we make sure that we make arrangements to gather data and make data available for removing the algorithmic bias that is present, is exhibited by machines. Mr. Olatunde, the best way to go from IT to AI, you're already halfway, you're just a few steps to AI. You can program, you understand networks, computer networks, you have various skills in making the computer do what you want. So all you now need is to understand the theory of intelligence. That is one curious thing about the computer. You find that at the moment you describe yourself as an IT person, really the amount of IT that you really are doing may not be as much as the knowledge of what you are using the IT for. You might find that maybe you are working in an accountant's office and you are working as a network administrator. You will find that more often than not, you will be engaging in what they are using the computers for. So you find that in that case, you are actually getting to understand what they are using the computer for. Remember, I said the computer is the first general purpose hardware, which is controlled by software to the extent that you can use it for anything. So you find all these people that are called IT people finding themselves in various areas that are even less IT than artificial intelligence. So it's not difficult to go from IT to artificial intelligence. The first thing you need to do is sharpen your skills with programming, or at least with understanding how to use various packages that give in-depth analysis of unstructured data. If you have any particular questions, you may get in touch. Thank you.
Thank you very much for that, those answers. There are more questions that have come in. Patience Usip has a question. He said, thank you, sir. Peculiarities in culture, data, and languages fault some of our researches, but data gathering is tasky and cost-intensive, requiring funding and time. So how best do we handle these complexities? So I guess the question again goes to highlight how more data can be made available and in a cost-effective way. So what can we generally do as a community of experts in IT, AI, to make sure that we have enough data available? Then there is Dr. Osondu Ogwike, who says that your speech considers various aspects of AI.
Sorry, I can't hear you. Can you please, there's a background noise.
All right, I just muted one of our question people. So the question is, your speech considered various aspects of AI, but you did not dwell much on sensory perceptions. In other words, computer vision, tactile perception, etc. Does it mean that this aspect of AI are not as important? So yes, that's the second question we have on the chat. Then I can see that Mr. Emmanuel is ready. Gazama, do you want to ask your question now? I've just sent an unmute signal to you. So if you are ready, you can do that. Mr. Emmanuel. Okay. I think there's one more person who will take the other question. That's from Morofu Olaleye, or Olalere, sorry. Morofu Olalere. Can you speak if you're ready?
Yes, I'm ready. Good afternoon,
Okay.
everyone.
Yeah.
Well, I want to thank our presenter for the wonderful presentation. Well, am I on? Hello?
Yeah, go ahead.
Well, with you.
Okay. Thank you very much. I want to thank Dr. Agbola for the wonderful presentation. Actually, this seminar will not be a kind of platform where we can know everything about AI. And of course, you will agree with me that the only place where people can know more about AI now is the ACTEL program. That's MSc and PhD program. I would like the presenter to talk briefly, because of our potential students that are online, to talk briefly on how the PhD program is structure. For instance, when is the form going to be available? Then what are the conditions for private graduation? You have to do some coursework and the rest, so that those that we have invited who want to be like master student or PhD student have to go with. Thank you very much.
Okay, thank you, Warufu, for that important observation. I must say that before we finally round up in the next few minutes, the program coordinator for AI, both at master's and PhD level, will give a small talk, and I'm sure he will address some of what you have raised. Yeah, thank you for that. Olayemi, can you quickly make your observation or question? Okay. Then Matthew, okay, I think we have addressed that. All right. Okay. There is no one else with a question. So, Dr. please. Hello?
Good afternoon.
Yeah, Matthew Omotosho, I called your name. Are you ready now?
Yes, I'm ready. Good afternoon, everyone.
Yes.
Yeah, I can't say thank you enough to Dr. Adegbola for such a wonderful presentation. It's so much enlightening. Thank you so much, sir. We're proud of you. My question, that some of the questions have been asked, but there's one I actually want to ask now. Sir, which programming language do you think is best, would you consider best fit for artificial intelligence? And then, can you hear me, please?
Yes, go on. We can hear you.
Yeah. Other questions have been asked, but to also save our time, I want to ask that question, sir. That which programming language would you consider best fit for artificial intelligence?
Okay. Thank you for that, Mr. Matthew. Okay, Dr. Adegbola, over to you, sir. Help us clarify these questions. Yeah.
Well, the first question from Madam Patience talked about peculiarities in culture, data, and all that. Yes. Let me start by saying, making a statement that I have of an awareness that I have gained in the last 20 years of my work, which I still find that many people don't take as seriously. And that is every question that technology answers is posed by culture. I will say that again. Every problem that technology solves was presented by culture. So it is important that we take culture into technology. As for science, science makes pretenses at being stolid. Science makes pretenses at being objective. Well, good luck to science. But technology is value-laden because it addresses questions raised by culture. It solves problems caused by behavior of people within cultures. So we cannot discount culture from technology. And a lot of the mistakes we have made in the past in our efforts to acquire technology and all comes from the fact that we did not appropriate the technologies to our culture. So with the information technology, the information, all these things we call information age and all that, it is of extreme importance. You know, in the industrial age, we find that all the countries of the world that touch science and technology to their children in their mother tongues, all of them have achieved industrial breakthrough. All the other countries like us who are teaching science and technology in foreign languages, not one has achieved industrial breakthrough. And that is very, very telling, even though we ignore it, but we ignore it at our own peril. So we must look at this very, very tight connection between technology and culture. Data is very costly. It will even be more costly to us because what we refer to as big data today is effectively free data. It is data that was generated not because somebody wants to do research. It's data that's generated because somebody wants to live. Somebody wants to live their lives ordinarily. So take, for example, somebody works as a publisher, publishes newspapers, and publishes newspapers every day. The language data that that person is generating was not generated for research, but it is available for research. The other day, I went to look at New York Times, their archives, and I got over 100 years of everyday publication of New York Times. There is hardly anything in the English language that would not have been said in those 100 years. So if you want to give that data to computer to study the language, it will be available. What we therefore need to ensure is that we will ensure that as we use our languages, as we live our lives, that we leave trails, that we create data, we create documentation from the use, from our everyday use of these systems. We should find ways of accumulating such data. These are the kinds of data that are being used to solve problems. Like I talked about the grammar on Google. Google didn't create anything special with grammar. It was just searching the whole of internet. Anytime Google comes across the word grammar, grandmother, nanny, nana, they will take it down and look at the photographs there and publish them as examples of grammar. So if we do not do same, then we will have problems. We need this, I mean, if there's anything that is really, really urgent for us as scientists in Africa, is to organize ourselves, organize our societies such that we generate data that will accumulate into big data. Dr. Sondu, yes, sensory perception, yes. Okay, well, if you look at it critically, you notice that when I was talking about when I was talking about human cognition, I did say a few things about perception. And one of the things I said is that perception is not intelligence. It is cognition that is intelligence. Now, there are lots of applications of data that is sensed data. You can subject those sensed data to analysis within any of those three main algorithms that I talked about: search algorithms, logic algorithms, and learning algorithms. You will remember that I talked extensively about convolutional neural networks. There's nothing you can do in image recognition and all these kind of things today that will not involve convolutional neural network. Tactile studies and all that, which are special areas in the area of robotics, will take a lot of specialization for us to talk about that at any level. Remember that robotics is just intelligent motion. So all what we have talked about today, about the general background, the general basics of artificial intelligence, they apply to all those areas that you have suggested. If this were a 2-3 day seminar, definitely we will go there. It is not that they are not important, it is that the core algorithms that are used in those special areas have already been covered. And if I must confess, I did say that, you know, my own area is human language technology, and I may have applied some algorithmic bias. So forgive me if you find that disturbing. Yes, the next question appropriately goes to Estelle to tell about how things will be organized from now on. Mr. Matthew Omotosho, what is the best program for AI? Any programming language is good for AI. But today, probably the richest programming language with libraries and various new developments for artificial intelligence will be Python. Personally, I'm a Prolog programmer. I love Prolog to bits. And there are things that Prolog will do that none of the Python, C++, C#, C Blunt, whatever cannot do. They cannot do efficiently. But to really, really be able to use and build upon foundations that have been created by other workers in artificial intelligence today, you need to have a very, very strong hold of Python so that you'll be able to use things like NumPy, TensorFlow, Pandas, and various libraries that are available for artificial intelligence. So I think Python might be it, but Java, C, any of the C flavors, C Oloboro, C#, C++, they are all brilliant languages, particularly once they are object-oriented languages. Thank you very much.
Yeah, thank you very, very much, Dr. Adegbola, for answering those questions. I think it's going to even, it's becoming more than just a teaser, and we're really, really learning so much. We're very, very grateful. So we're coming to the end of the meeting, the webinar. I can see some other questions that have been asked, but what we can say is that if we have not considered your questions, please feel free to interact with us going forward from this meeting. At Estelle, Our website is there. The contact information are also available there. So you can contact us easily.
If I may, it's also possible we could look at the questions, write the answers, and send them to the website, address those particular things, or send them. I don't know if this will go on YouTube. We can put it as part of the discussions.
Okay, all right. Thank you for that. So other questions coming in, we'll find a way to treat it and make it available. So at this time, I would like to, you can stop sharing your screen, sir.
Pardon?
You can stop sharing your screen.
Okay.
Yes. Okay. At this time, we want Dr. Greg Onwuadi. I didn't introduce him earlier, though I mentioned his name. He's online. He is a lecturer, senior lecturer in the computer science department, as well as a director of the study center. But more importantly, he is the general coordinator for the AI programs. And so we would like Dr. Greg to just give us a little bit more information about the A-STAR programs and the structure, what it entails, and how people can generally take advantage of the opportunity. Okay. So, Dr. Greg.
Hello, can you hear me? Hello, can you hear me?
Yes, we can hear you.
Okay, yeah, thank you so much, Dr. Adewale, for giving me the mic. Well, I must appreciate Dr. Adebola for a wonderful presentation. He really did a very good job in fact, it's become more than a teaser, like Dr. Adesina said. He went real deep into AI. So I wouldn't pause. I had wanted to... I wanted to just share a little slide with us, some slides with us. Permit me to just a minute, please. Wow. Just a minute, please. So once again, good afternoon, everyone. My name is Dr. Greg Onwuadi. I'm coordinating the AI program. Dr. Adebola has discussed extensively on AI, so I won't pause. I'll just run through what I have here and go straight to telling us about the program, Estelle program, and MSc and PhD and the short courses. Then essentially the aim, objective of the program, and then the admission requirements. And we scan through some of the core courses that's required in AI, whether at the master's level or at the PhD level. If you can see I'm trying to share my screen. Well, already we've heard a lot from Dr. Adebola, so I don't want to start taking any more of our time. We've learned what AI is all about. And we've seen essentially it borders on training machines to actually think and act or reason like human beings, conditioning them, whether it's neural network or however it is that you're processing the machines to think or reason like AI. Essentially, we see two broad categories of AI: the weak AI, and the very strong branch of AI. Of course, the weak angle of AI borders on the system designed to carry out jobs or activities like games, personal assistants such as Amazon, Alexa, Apple, Sarah, and so on. But when you come to the strong AI, systems are designed to carry out tasks that are otherwise reserved for humans, more complex tasks, complicated systems that are actually reserved for humans. Examples are like having cars, self-driving cars, or in hospital operation rooms where you have machines that are operating patients. So that's just an overview. So straight away, for the Estelle program in artificial intelligence, we have MSc in artificial intelligence, we have PhD in artificial intelligence, then we have short courses in AI. So for the MSc program, it aims to actually provide higher education skills that are relevant for the industry and for research institutes in Africa and beyond the scope of Africa. Of course, the ultimate objective is that at the end of the day, we want to equip graduates with the understanding of fundamental approaches to implementing intelligent behaviors in machines, and also to equip and produce computer applications that can appropriate AI concepts. Then at the same time, develop frameworks and design solutions to problems that is uniquely African and may not be adequately addressed by other imported AI technologies. And also to provide sufficient awareness of the importance of data analysis, how to communicate data, how to process data, and make productive inferences from it. All for more of the MSc AI, on that, more on the MSc AI, we can see at our website, which after I run through the PhD and short courses, I'll refer us to. So prospective students can actually go to the website and see, or let me just go straight to the website.
I think Dr. Adewale has done that.
Okay, you did that. All right, so anyway, that's the website. If you can see it, there you can see the various programs. The MSc Artificial Intelligence is there. You can see, the program requirements are there. Like I remember a student asked a question on the program requirements. The program requirements is there: bachelor's with a minimum of second class upper in computer-related degree in mathematics, physics, engineering, or other degrees with substantial mathematics content. Alternatively, you could have minimum of 3.5 points at PhD level in a computer-related program or computer science, engineering, or information technology. All this, I don't want to bore us much with all these details. The duration of the program is a minimum of 3 semesters and a maximum of 6 semesters. You come again to the PhD program. The PhD program, candidates must have 5 credits, including English, Maths, and other 2 relevant science subjects at O level. Then, of course, candidates with bachelor's degree from approved university must obtain a minimum of second class lower division with CGPA of 3.5 stroke, that is 3.5 over 5.0 scale. And then, of course, the candidates must have academic master's degree in relevant areas with a CGPA of 3.5 over a scale of 5.0. Then, of course, the thesis score should not be lower than 60% B. Of course, a master's degree in machine learning or closely related topic. Then all applicants are expected to be competent with programming. This is very important. Programming and a strong mathematical background, because AI essentially centers on having good skill in programming and mathematics. Then students should first contact potential supervisors from the list of facilitators that have interest to supervise such students, as they register for the PhD program. Then, of course, the duration of the program is a minimum of 6 semesters and a maximum of 12 semesters. This is for the MSc and the PhD program in AI. We have short course in the AI program also. The duration for the short course is between 1 to 12 weeks. So that is essentially that on the program. And then just to add this on the PhD program, the PhD degree program is an intensive research work. And the aim essentially is for students at the end of the program to make original contribution to existing knowledge. The PhD students are to take 18 unit core courses in their first year of study. And of course, the pass mark for all examinable courses is 50% in any semester in which the CGPA falls below 3.0. Students will be advised to withdraw. In any semester in which the CGPA falls below 3.0, the students will be advised to withdraw from the program. So that's essentially that for the short courses, the short course in AI, the MSc program in AI, and the PhD program in artificial intelligence. Like I said earlier on, there are core courses that we expect to encounter in the course of running AI, whether it's at the MSc level or the PhD level, will have to do with introduction to the artificial intelligence, machine learning, data sciences, natural language processing, like Dr. Agbola has informed us that is his main area of domain. Then knowledge representation and reasoning, deep learning foundations, from scratch, then human-computer interactions, robotics, statistics, and of course there will be practical section bordering on intelligence systems. These are essentially the core areas that the students will have to grapple with, whether it's at the MSc level or at the PhD level. So now I decided to chip in. Well, I know our time has been, we really spent time on this webinar, but we have details of all the programs. So in case we come on board, we'll be able to have access to the TPP of both the MSc and the PhD program. I don't want to also bore us with that. That's why I had to extract the core courses we will contend with. So once prospective students register for the program, they will have access to both the DPP for, that is detailed academic program for the MSc AI and the PhD in artificial intelligence. Yeah, I decided to add this because this aspect of the presentation, because I just felt that some students may want to ask which are the possible careers that, or profession that a graduate of AI will find himself, or which likely jobs are they going to get in the market. So I decided to pick 5 top career areas in artificial intelligence. Now, from the World Economic Forum, the Future of Job 2018, it reports and predicts that there will be 58 million new jobs in artificial intelligence by 2020. So in a nutshell, the career in AI is growing, and it's growing astronomically, it's growing fast. So taking a degree in AI, say at least an MSc with Estelle, gives you a very bright prospect, a bright future, because the field and career part of AI is rapidly growing, as you can see there in that slide. And of course, you know, it's not just enough to acquire the skill. You're expected to also be involved in practicals, and then also try and get hands-on experience outside the normal academic curriculum. This will give you an edge over those out there that are equally seeking for the same job prospects. So the job market is really huge in AI, but a lot of people aren't trained for it. Yes, resulting in above average job outlook for those who do have the skills needed to work in this niche area. So quickly, we have 5 top career areas in AI, in artificial intelligence. This is not to say these are the limited career areas in AI.
Hello? Looks like we lost him.
Yeah.
Looks like we lost him.
Yes, his network must have gone down, but I guess he was just rounding up anyway. Okay, he's finally gone.
Yeah.
All right. I think it's clear from what he has presented that AI, it's a selling career. It's worthwhile in the 21st century that we are in.
Hello?
Okay, yes.
Sorry, my network turned down. So, I'm looking at 5 top careers in artificial intelligence. So I've mentioned them. Can we still hear me, please?
Yeah, we can hear you.
Okay. So I've mentioned 5 of them, and we'll look at them briefly. I'm conscious of our time, so I'm racing to spare you stay longer on this teaser program. So before I run through a summary of these 5 top courses in AI that I've mentioned, I'd like to say that there are so many others. I'll just mention them and come to those 5 and talk briefly on them. There's so many others. We have machine learning intent, we have business development manager, we have in artificial intelligence, we have artificial intelligence specialist job as BPS technologists, we have data scientists, we have independent sales reps in Nigeria, we have Python machine learning intent, we have machine learning engineers, we have IT heads, we have Agile, Scrum Master, Project Manager, Business Managers, AWS learners. So many potential career paths in AI. But now restricting ourselves to these 5 top areas, I'll just take a brief overview of some of them. Number 1 is, sorry, I have a little mix up in my slides there. Yeah. Sorry. So number 1, the data analyst. From my research online, the responsibility of data analysts have to have a solid understanding of data itself. As we all know, data the skill needed to effectively communicate, the findings. After you got data, huge data, big data, you'll be able to know how to analyze this data and filter out the required information from the analysis that was carried out, on the data. And you can present it not just in terms of what is being submitted to, can actually interpret, what the results that was obtained from the data analysis. Then the job outlook here for a data analyst, they have positive career outlook. Their roles earn as an average salary of $59,614 per annum. And by 2020, there will be roughly 700,000 additional data-related job openings. That is summary for responsibility and job outlook for a data analyst. The other, it's the user experience. In general, user experience specialists are in charge of understanding how humans use equipment, how we use machines, how we use equipment. In terms of AI, a user experience expert, his responsibility includes understanding how humans interact with tools in order to develop functionality that better fits those human needs down the line. And the job outlook for user experience designer is quite positive as well. The average salary for UI designers is $73,971 per year. Though these are the top of their field, they also make over 100,000 naira annually. And the job growth in this industry is expected to increase by 21.1% by 2020, thus effectively increasing opportunity for those with right training and experience. The third on the line is natural language processing. Their responsibilities are that there are many applications of natural language processing. The responsibilities of the experts in this field vary. However, they use complex understanding of both language systems through which computers can successfully communicate with humans. And then their career outlook. There's real shortage of people in this role. And the average annual salary for those with natural language processing skill is $107,000 per annum. Then we come to the fourth one. We're talking about those in the research institute, research industry. Now, their role actually varies depending on their particular role in the research field. But without wasting time, no matter their specialization, all individuals in this show will work to uncover possibilities of technologies and then help implement changes in existing tools to reach their potential. Then, of course, their career outlook. All AI researchers at top companies, employees make between 300,000 and 500,000 per annum in both salary and stock. Individuals in base level AI research roles are likely to make an average salary of 83,490 annually. So you can see, and I agree with me, there are high prospects for people with a degree, master's degree or PhD in artificial intelligence. There's software engineering. Yes, even as a computer scientist, you can also be skilled in software engineering. But the difference here is that with the AI expert or AI professional adds intelligence, the intelligent component into the developed software, unlike the conventional software engineer. So the AI professional will incorporate the intelligent component into the development of software. Now, their career outlook, the career outlook here, they will make an average of 84 336 annum. And this is with potential increase for those with a specialty in AI. It's not just enough being a software, conventional software engineer, but if you have the AI skills and experience to make the applications more intelligent and more able to reason and function like humans, you have additional, you've added additional value and definitely have increased your earning power. You permit me to stop here. Thank you so much.
Yeah, thank you very much, Dr. Greg, for that exhaustive description. And I'm sure we all have better understanding about the prospects. So we have come to the end of this webinar. Thank you for everyone.
Hello.
Yeah, hello, Prof.
Yeah, but I just want to add that the ESTEL program also has scholarship opportunities for students that may want to engage with ESTEL. There is a provision for scholarship if you qualify. And also there will be internship such that within the program you will have an opportunity to work with industry or related fields. And you will also be expected to attend conferences and workshops that gives you a lot of interaction with what happens in the outside world. The program is wholly online. You will have access to e-learning resources and also be able to also use the virtual library the center will have, just in addition to what has been indicated. Thank you.
Okay. Thank you very much, Director, for that. So without any further ado, I would like to invite Professor Abdullahi, the Deputy Director of ESTEL, if he's still online, to please help us wrap up and give us the closing remarks. Thank you.
Good day, our respected panelists and other participants. We have come to the end of the day's presentation, and we really appreciate the contributions of Dr. Adegbola, which has been insightful and beautiful. And I think we are better informed now about the roles of IA in our economy or in our life generally. So we appreciate everybody. In fact, Dr. Wale has also anchored the sessions excellently as ever before. Dr. Greg has given us a rundown of the prospects of AI, which all of us are thinking of how we can key in and be part of the development that is, or the goodies that will be, that are available there. So we appreciate your participation, and we hope you will be with us within the month on the 25th and on the 30th for 8 other insightful presentations on MIS and cybersecurity. So thank you so much. Stay home and stay safe.
Thank you, Prof. So goodbye, everybody. So we'll come again next week, or no, this week, for the seminar, the webinar coming on cybersecurity, and then management information system will come up on the 30th. Please watch out to invite everyone to come. Bless. See you soon.
All right. Thank you.
Thank you. Bye.